Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you so that we can start with this session. And today we are going to do biomolecules and quantitative qualitative analysis, right? And if you talk about for JE aspirants, right, biomolecules they find quite difficult. Reason being, maths is still digestible, ma'am, but this biomolecules, glucose, these structures, right? All of this, NEET aspirants find this easy. But definitely, I completely understand. So I'm going to teach you the same way, right? I'm also from a maths background only, right? Even I don't have bio background. But, right, in chemistry, how to learn biomolecules for those students who have never learned biology, right, in class 11th and 12th, that we are going to see. We will focus on the structures so that you can easily draw the structures yourself. We'll focus on some important tricks here, right? So I can completely understand your pain, but uh, it's easy if you understand this with the help of tricks and you deep dive into the concepts. You will see very direct questions are asked here from biomolecules. Second is qualitative quantitative analysis. Now, the first part of that, purification of organic compound, I have already taught you that. Now, from qualitative quantitative analysis, we have seen in 2025 itself, they've asked you a lot of questions from there, right? Curious method, percentage of sulfur, percentage of halogen, Dumas method, Kjeldahl's method, right? So all these methods they ask you and they are very simple, just direct formula based answer questions they are. So we are going to discuss that as well. Right, everybody? So don't do let me know, ma'am. Yes, these won't scare PCMB students. Yeah, those who have biology, they won't get scared from biomolecules. Reason being, more advanced version of this biomolecules is there in bio, right? Where structure is just a little part, right? So you just have a little part that is actually a part of chemistry, right? In your chemistry part. So definitely if you're a bio students, then you are PCMB students, you also have bio, then you like it's an easy thing for you. But for PCM students, it is definitely structure and all. Calculations, physical chemistry is still easy, but ma'am, this one, organic is ma'am still okay, but what is this, ma'am? All these structures. So today we are going to make it easy for you. So let's talk about that, right? Okay, everybody. And before someone asks me, ma'am, how long this lecture is going to be, let me tell you. See, I'll give you breaks in between. Approximately what I assume is 3 hours, you can see, for biomolecules, because we will be doing it in detail. I will not be doing just your revision. I'll be solving questions here. If you watch this lecture, you don't have to watch anything else for biomolecules and qualitative quantitative analysis. That's my guarantee to you. That is your final thing that you're doing. After that, even PYQs I am discussing here. So you don't have to do anything after this, right? So that is sorted. So for that thing that you don't have to do anything, you need to invest your time here. So 3 hours you can expect for biomolecules, and you can expect qualitative quantitative analysis like 40-50 minutes for qualitative quantitative analysis, right? With the breaks we can say like around 4.5 hours it will take. And at 8:30 or 8 p.m, whatsoever we feel, I think 8:30 I'll give you the break. Right, everybody? Okay, yes. Now let's talk about that. Let's talk about that. If you talk about this, carbohydrates. So now biomolecules is divided into carbohydrates. First, you will understand carbohydrates. Then we will understand proteins, amino acids. Then we will understand DNA, RNA. These are the three parts of biomolecules, right? In carbohydrates, majorly we are going to discuss about monosaccharides, disaccharides, polysaccharides, and we are going to discuss the structure of glucose, fructose, maltose, sucrose, all these things, right? The confusing part is the almost all the structures are quite similar, and that is why students get confused in that, right? But don't worry, just remember, right? Full focus should be here on your screen, and these are perfect notes for you that will be provided in the description box, right? Now let's start this. What are carbohydrates, right? We eat carbohydrates, right? You eat rice, you eat wheat, all of this has a lot of carbohydrates, right? Why we say that if you eat wheat or rice, it has a lot of carbohydrates, and less of protein and all is there in these things, right? That's why we say eat less of rice and wheat and more of these fruits and these protein based things like cheese, paneer, and all these things. You should eat that more, right? Reason being because our body already is having a lot of carbohydrates, right? So carbohydrates, if you talk about sugar that you have, that is carbohydrate. Glucose, it is carbohydrate. Sucrose, that is carbohydrate. Fructose, that is from the plant, that is from the fruits, that is carbohydrates. So all these are a form, they are very sweet. So all these are sugars. So carbohydrates may be defined as optically active polyhydroxy. So in the form of chemistry, now understand how do we define carbohydrates. First thing is we are saying that optically active. Optically active means here you will have at least one chiral carbon. Chiral carbon means what? Now everybody tell me, what do you mean by chiral carbon? What do you mean by chiral carbon? See, chiral carbon is, which is sp3, and it has 4 different groups attached to it. So in all the carbohydrates, what you will see, there will be at least one chiral carbon that will be present in all these structures. At least one. You will see more also, but at least one will be present in all the carbohydrates. Polyhydroxy means they have more than one OH group here. You will see around 4 or 5 OH groups. And then they can be aldehyde, like glucose is an aldehyde. And ketones. Ketones means like fructose is a ketone, right? Or the compounds which produce such units on hydrolysis, right? Or there can be those compounds that produce these units on hydrolysis, right? Some of the carbohydrates which are sweet in taste, also called sugar. So I told you glucose, you have tasted it, it's sweet in taste. Sucrose, you talk about fructose, all these are sweet in taste, right? Most common sugar used in our home is named as sucrose that we eat, right? Then whereas sugar present in the milk is called as lactose. Now that's why we say lactose intolerant, those who are not able to digest lactose, that means this particular sugar they are not able to digest, right? Lactose intolerant, right? Because in milk you have lactose sugar, right? Carbohydrates are also called as saccharides. So saccharides, it's another name of carbohydrates that we used chemically, right? In chemistry we use the name carbohydrates, right? Now carbohydrates are classified based on what things? Let's understand that the classification. First thing is that a carbohydrate on hydrolysis gives what? Based on that you have the classification. So first thing is, based on hydrolysis, if you have monosaccharides means they on hydrolysis cannot be hydrolyzed further to give simpler unit of polyhydroxy or this. That means like you have glucose, fructose, right? When you hydrolyze it, they are not going to give you another unit which is polyhydroxy ketone or polyhydroxy aldehyde. They are not going to give you that unit. That means they are monosaccharides, right? And if you talk about oligosaccharides, these on hydrolysis that yield 2 to 10 monosaccharides unit on hydrolysis. 2 to 10 units. This you can see the case of sucrose, right? Lactose, we'll study the structures as well. Maltose, right? These are the units which are going to give you like more than like 2 to 10 units, right? Polysaccharides are which give you large number of monosaccharides unit on hydrolysis, and we will discuss each the structure of monosaccharides, oligosaccharides, polysaccharides. As of now, just remember monosaccharides, no units on hydrolysis. Oligo will give you 2 to 10 units on hydrolysis, 2 to 10 units on hydrolysis, and this gives you large number of units on hydrolysis, that is polysaccharide. Now let's understand in depth of monosaccharide, right? Monosaccharide are further classified into number of carbon atoms and the functional group present in that. So first is if it contains aldehyde group, second is if it contains ketone group. Aldehyde group is there present in that is called as aldose. Like glucose has aldehyde group, you will see the structure, glucose has aldehyde group, right? So the one that has aldehyde group, ald from here, and because they are like they are monosaccharides, so they are called as ose. So this is aldose, right? So this contains keto group, so this is ketose, right? Okay. Now I'll write the examples as well. Here the example is like you have glucose. For example, you have glucose. Here, for example, you have fructose. Fructose is the example of which has ketone group, right? Now, if I talk about based on number of carbon atoms and the aldehyde or ketonic group whatsoever it has, how they are named, let's talk about that. If you have 3 carbon atom, always there will be tri, 4 carbon atom will be tetro, 5 will be pent, 6 will be hex, and 7 will be hept. And in the end it is os, right? OSC, that is written in the end, right? Tri, tetra, pent, hex, and hept, right? Now if you have aldehyde, you will just write here aldo in front of all of them. So it becomes aldotriose, aldotetros, aldopentose, aldohexose, aldoheptose. If you have ketone group, apply keto in front of all of them. So this will become ketotriose, ketotetros, ketopentose, ketohexose, ketoheptose. Right? Simple, right? Now, let's understand, out of this, one of them is glucose, one of them is fructose, that we will get to know, right? That which one is glucose. Because now one question in 2021, they have asked you based on this thing. They have asked you the name of fructose in this form. That's such a simple question, right? If you know the structure of fructose, that is a very simple question, hardly in 2 to 3 seconds. Now, I posted a video in the shorts form. I posted a video where I was talking about 30 to 35 questions, around 35 around question you should do in first 1 hour. Students were like, ma'am, how this is possible? This is possible, right? If your paper is what the pattern we have seen before, in chemistry you have high chances, in mathematics I won't say, right, maybe 1 or 2 questions. In chemistry you can find a lot of questions like that, and in physics also you can find a lot of questions like that. Not too many, but still you can find, right? Even if you find 6 to 7 questions from physics and some 10 to 15 questions from this, chalo, minimum, let's say the paper is hard, you are able to find 25 questions or 20 questions which are quite easy, doable in just 30-40 seconds. This much will be there. Some questions maybe it will take you 1 to 2 minutes, right? But you can easily find those easy questions. I'll just show you those questions as well. And these are the chapters that give you those kind of questions which can, inorganic chemistry and these chapters, they give you questions which easily you can solve within seconds, right? Now let's see the preparation of glucose, right? What is glucose? Glucose is C6H12O6. That is glucose. In the earlier classes, you only used to do this. Now, glucose and fructose has the same formula, right? But in case of glucose, you have aldehyde group. In case of fructose, you have ketonic group. So that is why if you ask me, ma'am, which of them is glucose and fructose? So this one is glucose. This one is glucose. which has 6 carbon and it has aldehyde. The one which has 6 carbon, it is having ketone, that is fructose. So another name of fructose is also ketohexose, right? Okay, that simple question was asked to you, right? Now let's understand the reaction part of glucose, how it is prepared. So it is prepared from sucrose, that is a cane sugar that we eat at our homes, right? If sucrose is boiled with dilute HCl and H or H2SO4, that means in the presence of an acid, what exactly happens here? Alcoholic solution, glucose and fructose are obtained in the equal amounts. These two things are formed here, right? That is the preparation of glucose. Another is from starch. Now, if you talk about sucrose, that is oligosaccharide, because if you see, it has 12 carbon atoms, it has 22 hydrogen and 11 oxygen. So basically what it is forming, when it is being hydrolyzed, right? Sucrose, I'll tell you, this is under oligosaccharides. That means it is made up of more than one uh, monosaccharides, right? So actually sucrose is made up of glucose and fructose. That is why on hydrolysis it is giving you glucose and fructose, right? Okay. Now if you talk about starch is made up of n number of glucose molecule joined together. If you have ever done polymers, right? So polymers is what? Linkages are there, 2 to 3 molecules. If you have you ever seen, like let's say this is the unit, okay? This is the unit. Let's say, wait a minute, we connect few things, okay? Let's say I connect few things here. So this is the wire. Now what I am doing is I connected this wire to this wire, then I connected this wire to this wire, right? Now this is how these oligosaccharides are formed. This is, let's say, one monosaccharide, this is another unit of monosaccharide. So firstly I'll connect these two, then I'll connect these two, right? Then further I'll connect other molecules here, right? Further I'll connect this one to this one, okay? So these are the connections that I am doing. Same connections are in chemistry, right? That is the reason starch or cellulose, that is made up of n number of glucose molecules joined together, when they are hydrolyzed, they give you back n number of glucose molecules here, right? That is from the starch, that is a commercial preparation of glucose. Now let's talk about, ma'am, we are talking about glucose, but what exactly is the structure of glucose? Let's talk about that. Yes, everybody? Yes. Right? Yes. No, Rasik. Okay. Now let's talk about structure of glucose. So what we are saying, glucose is C6H12O6, right? How it is done? So you have 6 carbon atoms, right? All the carbon atoms, 5 carbon atoms will have OH, 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 and one will have CHO. That is your glucose, right? If you want to write it, you will write it like this: CHO, then 4 CHOH you will have, then you will have in the end CH2OH. Why this is CHOH? Because to complete the tetravalency, you need only 1 hydrogen. Here you need 2 hydrogens, okay? So that is the structure of glucose. Now I am not giving you that where on the left side or right side OH, that also we'll talk about, right? So if you see this here, glucose is aldohexose and is also known as dextrose. Now why this is called as dextrose? Let's talk about this. In isomerism, I told you there can be small d and small l. Small d is dextrorotatory and small l is levorotatory. This rotates the plane polarized light towards the right, and that is why this is also called as positive. Dextro, I'll just write this here, dextro, right? that is represented by small d, that is written as positive. Then there is levo, that is written by small l, that is negative. And that is why in glucose you will always see this positive and then d here. This represents that this is dextrorotatory. It rotates the plane polarized light towards the right side. Okay, it rotates the plane polarized light towards the right side, and this rotated towards the left side. Now, if I talk about this here, that's why this is dextrose. It is monomer of many larger carbohydrates like starch. Like starch, when it hydrolyzes, it gives you. That's why monomer means the single unit. By connecting those units, you have a polymer, right? So starch is a polymer that is made up of small monomers of glucose, which are connected to give you a big molecule. So for example, I have any structure like this structure. This structure, this is the simple molecule only. Just imagine that here you have one glucose, other glucose, third, fourth, fifth. So what is happening here? These all are made up by connecting them, right? Similarly, by connecting so many glucose molecules, you have starch. It is probably the most abundant organic compound on the earth, as you can see this over here. Now, evidence of structure of glucose. Who told you that this is the structure of glucose? How we can get to know that? Now, these reactions are also very important, based on which they can ask you, firstly, directly the reaction, or how you identified that it has 5 OH groups. It has 6 carbon atoms. There is an aldehydic group here. There is no ketonic group here. How you identified all of that? So glucose is in our syllabus, that how it is identified. It is written in your NCERT, right? So molecular formula of glucose is C6H12O6. So how we got to know it? If you have any molecule that you are saying it is glucose, when you add it in HI, right, in excess, and you heat it, what is going to happen? This is going to get converted to N-hexane. So glucose, it upon reaction with HI gives you N-hexane. Carbons are connected, that means carbon, it has 6 carbon. First thing is, because it is giving you hexane, that means it is having 6 carbons. And because there is no branched structure here, there is normal hexane you are getting. You are not getting isohexane or neohexane. You are not getting. You are getting a normal straight chain. That means the glucose carbon are connected in a straight chain like this. Okay. This means when you have with reaction with HI, you got to know this. Then when you react this with NH2OH or HCN, then what will happen? Let's talk about that. If you talk about with NH4OH, right? Now, do you remember this thing? I told you one thing in aldehydes, right? What we discussed. Tell me how many of you remember this. If you have any ketonic, till now I don't know whether it's ketone or aldehyde. I am just trying to do reactions here. So this particular reaction is shown by aldehydes and ketones both, right? If you remember, this is the reaction that we saw, and we know that water will be released, and this is going to give you this kind of compound, that is C double bond NZ, isn't it? Now, if it is going to give you, that means if you have here, let's say Z is OH, right? If Z is OH, then what we used to have, we had the formation of, this was called as oxime. This was called as oxime. So that means if here you have the preparation, you have the product formation of oxime, that means we can guarantee that there is formation of, there is presence of aldehyde or ketones here. So confirms the presence of carbonyl. Till now, I am not saying that aldehyde is there. I am saying maybe aldehyde, maybe ketone is there, because it is giving this reaction here, that is for aldehyde and ketone. So this C double bond OH is converted to NOH, that is NOH, double bond NOH, that is connected to this, that is oxime is formed, other things are as it is, right? When you react aldehyde with CN, tell me what happens. Who will tell me? When you react aldehyde with CN, what is formed? This also we have done, everybody. This also we have done. This also we have done. When you react aldehyde, you have C double bond. Oh, this is HCN, H positive, Cn negative. So what will happen? This Cn is going to attack here. Electrons are going to jump here. You will have C. This is O negative. This will be H will be connected here. So this will be COH. And here you will have two bonds and this will be Cn. This is cyanohydrin that is formed here. This is cyanohydrin that is formed. This is the reaction that you have here for the carbonyl groups that you have. With carbonyl, it can be aldehyde, it can be ketone. It is giving you this reaction. Yes, ma'am. Ma'am, with carbon, we have the presence of, CN, OH, ma'am. Yes, OH is present. That means, can I confirm? Yes, carbonyl is present here. Can I confirm this? Yes. Yes, notes will be provided to you in the description. You don't have to write anything, guys. Very few days are left. Just understand things. Notes will be provided to you, right? Okay. Now see this over here. You have the presence of, there is no new reaction. You don't have to learn this. These two reactions are old reactions only. It's just that other chain you have that you have to write it as it is, right? That means carbonyl group is confirmed. Now, how do you confirm that aldehyde is present, ketone is not present in glucose, right? Okay, this they can ask you, which of the following is the reaction where you are confirming that aldehyde is present, ketone is not present? This is that reaction where we are saying that bromine water is a very good oxidizing agent, right? Now, if you remember, bromine water, what it is going to do, it is going to convert CHO group to C double bond OH. And this reaction is not shown by, this test is not shown by ketones. It is only shown by aldehydes. So if it is converting CHO to C double bond OH, then we can say there is presence of ketone over here. So proves the presence of aldehyde group, as ketone do not oxidize to acid in presence of bromine water, right? What conversion, what thing you can see over here? I'll just mark it in red. Here you can see CHO is being converted to COH. Here you can see CHO is being converted to this oxime part, and here cyanohydrin part, right? So these are all the justifications. And what this is called, then in the glucose, CHO group is converted to COOH, that is called as gluconic acid. Saccharic acid is different, okay? Some call it saturatic acid, hai na? Don't go with the pronunciation, right? I call it saccharic acid. Okay, gluconic acid, guys, if you talk about, this has only one COH group. If you have two COH group, if you have a oxidizing agent that is even able to oxidize this thing, then it will form a different compound. Let's talk about that, okay? We'll talk about that oxidation as well. Now see one thing, right? Now you are confirmed. How many things we have confirmed? We know that it has 6 carbons. We know that 6 carbons is in the straight chain. We know that it has one aldehyde group. It does not have any ketonic group. That we are sure about. Now, who will tell us, ma'am, there is OH group? Why it is polyhydroxy? So let's talk about the test of hydroxy groups here. So what you do is, you have acetic anhydride or acetyl group. What this is, we are adding acetic anhydride here, right? Acetyl group. AC means nothing. AC is this thing, CH3 C double bond O. This is O, C double bond O. This is CH3. This is called as AC2O. Okay? Now if you have this group here, now what we are doing, what it is getting converted to, all the OH groups are getting converted to OAC. Now, if what is happening here, if you remember, right, in case of alcohol, you have anhydride with alcohol, it gives you ester and acid. This is the reaction that we have, right? Anhydride that is this thing, this is an anhydride. Anhydride you are adding with alcohol. If there is any alcohol present, it will give you, if I say this is ACO, this is OH, it is going to give you, if it is connected to some R here, or you can say COH, let's say this is C, you will have the formation of ACOC. This will be formed here. This is what we call, this is this is carbon, this is oxygen, this AC is CH3 C double bond O, right? So overall what it is giving you, so I'll just write it here, AC2, this is alcohol, let's say you have written R here, right? It is going to give you, this R is connected to this one, so it is going to give you ACOR. That is nothing, what is AC? AC is nothing, CH3 C double bond O, OR. This is the AC group here. What is acetyl group? This is the acetyl group. This is the acetyl group. That is called as AC. Right? Okay. Yes. Because this particular reaction, it was not giving. Na? If it would have been ketone, this reaction it should not give. It should not give acid here. It is giving you acid. That means definitely, see, if you remember in aldehyde, do you remember one aldehyde is converted to COH. Ketone, whether you have any oxidizing agent, it is not converted to COH. This is not that of a strong oxidizing agent that it converts ketone to acid. So that's why we can say that aldehyde is converted to carboxylic acid. So definitely aldehyde is present here, right? In this case, because after this reaction, you have the formation of how many OAC? 4 here, and this is 5. So total 5 OAC are formed here. That confirms that there is presence of 5 OH group. Confirms the presence of, presence of 5 hydroxy group. Okay, this reaction will confirm that. Even now, we are not sure that which of them is primary, which of them is secondary. That we are going to talk about now, right? So acetylation of glucose, if you see with acetyl, it gives glucose pentacetate, which confirms presence of 5-OH group. It exists as a stable compound. 5-OH group should be attached to different carbons. Now we know that 5 OH group are there, then how can you say that they are attached to different carbons? They can also be attached to the same carbon. But I told you, throughout in organic chemistry, we have learned this one thing, that on one carbon, 2 OH are never stable. So, but glucose is a very stable compound, right? Glucose is stable compound. That means one thing I can confirm, that if glucose is stable, that means each carbon, 5 carbon, they have OH attached to them, right? Okay. Now, next is concentrated HNO3. You have glucose, you add concentrated HNO3, then what will happen? So in concentrated HNO3, what will happen? The work of concentrated HNO3s, it is so strong, it converts CHO to COH and it converts primary alcohol to COH. Acha, do you remember secondary alcohol is not converted to COH? Do you remember that? 2 degree, if you remember, I told you strong oxidizing agent, primary is getting converted to carboxylic acid. Secondary with strong oxidizing agent is not getting converted to carboxylic acid. So secondary alcohol will not get converted to carboxylic acid. You will say, ma'am, but it should get converted to ketone. If you say that this secondary, ma'am, it should get converted to ketone, then it has to break all these bonds, which is not possible. This is not that of a very strong oxidizing agent that it starts breaking the carbon-carbon bond. So that is why no reaction will occur with the 2 degree alcohol. So that confirms that after this you have the formation of saccharic acid, that is, you have here 2 COH groups. even secondary is getting converted to COH, aldehyde is getting converted to COH. That confirms that you have the presence of you have the presence of one primary alcohol, right? And you have 4 secondary alcohol here. That means how many primary alcohols you have? 1 primary alcohols you have. And how many secondary you have? You have 4 secondary alcohol here, right? That confirms it, right? And saccharic acid, you can also prepare it from the gluconic acid. Gluconic acid, which is only one COH, on further oxidation, even this will be converted to COH. That gives you saccharic acid, right? Okay. Tell me, is that clear? Yes, Sion, it is already completed. Yes. Done, everybody? Understood? So on oxidation with nitric acid, glucose as well as gluconic acid both yield dicarboxylic, that is saccharic acid, right? That says which thing? Indicates the presence of primary alcoholic group in the glucose. That means there is one primary alcoholic group that is present here. So here from this we can say that there is an aldehyde. There are 1, 2, 3, 4 secondary and 1 primary alcohol here. Okay, this defines the structure of the glucose. So glucose is concluded as 5 this is aldehyde. Okay, the structure of glucose is this thing. Right, everybody? Tell me. Now we'll move further. We'll tell you that the stereochemistry of glucose, how Fischer structures are drawn. Right, the examination of stereochemistry of glucose was done by Fischer and he gave the following structure. So what is the structure? Let's understand that. See, you will draw a straight line. You will draw one CHO group here. See, you will draw a vertical line. You will draw 1, 2, 3, 4 horizontal lines. Here you will draw one CHO. Here you will draw CH2OH. Now all of them will have 1, 1, 1, 1 OH, but stereochemistry will tell you, we know that this carbon is not chiral. Firstly, you need to tell me which carbon is chiral, which is not chiral. Okay? Which carbon is chiral, which is not chiral. Okay? So you have this thing, right? Draw a vertical line, draw 1, then you have 2, 3, and 4 lines here. Now what you have here? Now let's see what you have here. Right, now let's see what you have. What you're going to write here. This is CHO, right? This so we have already seen as well that this is going to be CHO. Right, this is CHO, right? And the last one will be CH2OH. That you know already, right? That is not a big deal. But what about these OH and H here? Tell me, is this carbon chiral? Chiral carbon should have 4 different groups and it should be sp3. Here you have C, 2 hydrogens and 1 OH, then this whole group here. That means it is definitely not chiral, right? What about this one? What about this one? This is actually C double bond OH. So this is 3 sigma bond. So it is sp2. And sp2 carbon can never be chiral. Chiral carbon, the condition is that chiral carbon is that carbon which has, I told you in the starting of this lecture as well, there should be sp3 and it should have 4 different groups here, that is there. Okay, acha, tell me now one thing. Here if I draw, this is HOH. Now I am not telling you the stereochemistry. Just tell me if I draw this simply. Now this carbon has 4 different, this carbon has 4 different, this. All these 4 carbons are chiral here. So I'll just draw this. Okay, the star means all these 4 carbons are chiral. So in glucose you have 4 chiral carbons, where what you will see only in the 3rd carbon OH is on the left side. That is a very important point, that in case of glucose, 3rd carbon Just remember this. Third carbon, OH is on the left side. OH is left side. That's it. Just remember this thing, right? Just remember this thing and draw the structure here. Here you have what? Here you have OH. Here you have this is first, second, and this is third carbon. On third carbon, OH is over here. Others OH are on the right side. Okay, this is H, this is H, this is H, and this remaining is H, right? And that gives you the structure with the stereochemistry for glucose, right? Okay, yes. Yes, that's what I told you, that CH2OH and CHO are not chiral here. Only these four are chiral. Okay? Yes. Now, if you talk about gluconic acid, convert this CHO to COH. If you talk about saccharic acid, convert this also into COH. And wait a minute, here it should be COOH here, right? It should be COOH here, right? Okay. Yes. Wait a minute. Let me just correct this thing. Okay. Got it, everybody? That forms the structure of glucose here, right? Now, let's talk about, now tell me one thing. In glucose, if I write positive, what do you mean by that? That simply means it is, see, small d and capital D has no relation with each other, right? Small d and capital D does not have any relation with each other. Small d defines that the plane polarized light is always on the rotated on the right side. That is small d, that we represent by this positive sign. But what about this capital D, glucon D, right? There is always glucon D. Why it is glucon D, right? I don't know why company has made it glucon D, but I'll tell you why here it is D. D represents the configuration and is not related to sign of the optical rotation that I told you. Small d tells you the sign. Capital D has no relation with the sign, optical rotation, no relation with that, right? Capital D and capital N relative configuration of particular stereoisomer, that says it is done by choosing simplest carbohydrate glyceraldehyde as a reference. Let's talk about that. If you have the last chiral carbon, this is the last chiral carbon that you have. If here OH is on the right side, it will be capital D. If OH is on the left side, that will be capital L. That is a simple differentiation. Small d and small l are different. Capital D and capital L are different. They have no relation with each other. Why I'm telling you? Because based on this also they have asked you a very simple question, right? We'll see this when we'll start doing the question. Now, failure of state change structure. Why state change structure were not able to give reactions that was given by glucose? Let's understand that. State change structures fails to explain the following properties. This also they can ask you which of the following gives you, which of the following tells you that state change structures are not possible, right? You have to take it. Statement based question can be asked. So glucose does not show 2,4-DNP test. 2,4, acha, tell me 2,4-DNP. If I say in this case, tell me, is aldehyde free? Is aldehyde free here? Aldehyde is the free group here, isn't it? Aldehyde is totally free. So it means all the reactions given by aldehyde should be given by glucose. So 2,4-DNP test, if you remember, it is given by aldehyde. So now from that, what we should know that, ma'am, it should also give 2,4-DNP test, but it does not give 2,4-DNP test. Schiff's base test, it is also given by aldehyde, but it is not given by glucose. NaHSO3 test, again it is given by aldehyde, it is not given by NaH addition product, that is formed by aldehyde, but that is not formed by glucose. Why? The pentaacetate of glucose does not react with NH4OH to form oxime. And what we have seen, that the pentaacetate, when you have OAC linked here, when you react this with glucose, it does not convert does not form oxime. Oxime is formed by simple glucose, but when you convert it into acetate, then it does not form oxime. Now, why are these abnormalities here? This is because our structure is not complete yet, right? Aldehyde does not exist in free state, right? Though state chain on direct reaction forms oxime, cyclic structure does not. If you have a state chain glucose, it will form oxime. But there are some portions where glucose will not form oxime. Reason being because now CHO group is not available only. It is in the cyclic form. So now let's understand what is the cyclic form. Both these observations indicate the absence of free CHO group. CHO group is not available for the reaction in the cyclic part. Now let's understand what is this cyclic part, right? Okay, let's understand what is this cyclic part, where firstly I'll just talk about cyclic structure now. First you will talk about this, right? Okay, cyclic structure actually has alpha and beta, two kind of structures are there, but firstly I'll talk about only the alpha structures, right? Yes. Is this high weightage topic? When I'll teach you na, then you will get to know yourself, right? See, okay. Now let's talk about this thing. If you have this structure, okay, how firstly the question is, ma'am, how this structure is formed, right? Let's talk about that, how this structure is formed. So actually what you have initially is you have CHO group here, okay? I'll just draw this thing over here, okay? I'll just write which thing here, this I should write over here, and this wait a minute, let me just tell you. Okay, chalo. Firstly, let's see how to convert. I'm just copy pasting this slide. Acha, see how to convert CHO to this. A conversion, do you need to remember that or not? It's not like, but you should know that how it is happening, right? So let's talk about that. If I have this thing, if I have, this is CH, this is the glucose, right? This has 1, it has 1, 2, 3 and 4, right? These 4 groups here are there, okay? Acha, now if you see this here, this was C double bond OH, right? This is H, this is OH, this is, say third is, this is OH here, this is H, this is H, this is OH, this is H, this is OH. In the end, I'll give you a direct way of remembering this, but as of now, just remember what is going to happen here. Okay, what is going to happen here? Remember that, how we are going to do this. You should know, otherwise in exam, if you forgot that what is the structure of glucose, then you will end up doing a lot of silly mistakes here, right? So this is a group, right? It is connected, let's say this is 1, this is 2, let me write it over here. So this is 1, this is 2, this is 3, this is 4, this is 5 and this is 6. With 6 carbon it has to do nothing. But what will happen here, you will have OH and here you will have CHO. What will happen here, this particular hydrogen, right? This hydrogen, the connection you will see from this carbon to this carbon, there is the connection, okay? So this carbon to this carbon, there is the connection, and this hydrogen, if you see, this hydrogen, exactly what will happen here, this electron, this bond will shift here. When this bond is shifting here, what will happen here? Here you will have single bond, and this will be O negative here, this will be O negative here, right? And this hydrogen will be shifted there, and this hydrogen will be shifted there, and it will have OH, right? It will have OH. Okay, it will have OH here. So I'll just write down hydrogen here. It will have OH here, right? So this is the cyclic structure that you are going to have, that we write like this. We connect the first carbon with the fifth carbon. First and the fifth carbon is connected. And on the first carbon, if you see, you have the addition of, you have double bond O is converted to OH now, right? That's how, when you were drawing the simple structure here, when you were drawing this particular structure here, when you were drawing, wait a minute, when you were drawing this structure here, we used to say third carbon OH is on the left side. But when you see this structure now, what you will feel, ma'am, now 1, 2, 3. Ma'am, this is third carbon, OH is on the left side. But ma'am, now on the first carbon, you have OH. But before first carbon didn't have any OH. But now it has OH, right? This is all what you have to remember here. And that's it. That is your structure of glucose here. Now, how alpha and beta is divided? Now, based on whether this OH, because see, as of now, you can see this over here, this second, third, fourth, and this will all fixed. But one thing is not fixed, that is this thing. This particular thing is not fixed. We don't know whether on first carbon the OH is on the left side or on the right side. So based on that, you have two things, right? First is alpha glucose, other is beta glucose. Alpha glucose is, when I say, let me just write it over here. Alpha glucose is when I say OH is on the right side, and beta glucose is when OH is on the left side. That is the only difference that you have. I know you are finding it very difficult, but I'll just draw the structures all along with you only, right? And you also draw it with me, right? So you'll find it quite easy. All you have here is draw the simple 1, 2, 3, 4. This is CH2OH. First carbon is connected to the fifth carbon. 1, 2, third carbon, na? So this is the first 1, 2, 3, 4, 5. Why it is 5? So it will be 1 OH here, right? So third carbon OH is on the left side. Other second and third carbon OH is on the right side. That is for sure. But now if here OH is on the right side, then it is alpha. But if OH is on the left side on the first carbon, that is called as beta. That's the only difference that you have. Do let me know, guys, if there is any problem here. Ma'am, how to draw its cyclic structure? Simple thing is how to convert this thing to this thing, right? Here, if you know how to draw this structure, you don't have to remember this, right? What you remember that down means right. Down means right. Always remember dr. Diksha ma'am is always right. Dextro is right. It is rotating the plane polarized right towards the right. Capital D is, ma'am, when OH, the last chiral carbon has OH on the right side. Okay. Ma'am, what is down? Down also means right. So dr. Diksha ma'am is always right. Just remember this thing, right? So left, if you say up means left. So now if you see this structure, just draw the pyranose ring. That is a 6-membered ring. And on one carbon, you draw the oxygen. Now draw straight, up and down here. Now draw 1, 2, 3, 4 here. This is, let's say 1, this is 2, this is 3, this is 4, this is 5. And this one will be 6. On 6, you will have CH2OH here. Sixth, there is no left right, so it will be written as CH2OH directly here. Now see one thing. On the first carbon, on the right side, whatever is right side, that will be down. So on the right side, you have OH. On the right side, you have second carbon OH. On the third carbon, you have hydrogen. Fourth carbon on the right side, you have OH. On the fifth carbon, there is nothing, no left and right. So one CH2OH here and one hydrogen here. Rest of it you write it here and you will have your answer. ठीक है? Okay. Acha. Shall we now draw all the structures here? Right? Shall we now draw, because we have done all the structures here, right? Alpha glucose, if you talk about, that has melting point less as compared to beta. Crystallization of concentrated solution of glucose at 303. Crystallization of, this is formed after of hot concentrated solution at 371 Kelvin. Alpha is prepared at room temperature and beta is prepared at 98 degrees Celsius. Right? Okay? Understood? Yes, everybody? Tell me. We know that glucose exists as 6-membered ring, oxygen. Now this all is vertical. This all, so I'm deleting this. Hai na? This is nothing. Okay. Acha, tell me now, shall I draw the structures of glucose with you? Direct thing that you have to remember. Okay? Okay? This page has all the things that you have to remember. Shall we do it? Who will do it along with me? Who will do it along with me? Tell me. Who will draw the structures along with me? You will have this confidence that they are not difficult. Pick out pen and book. Right? If you're not picking that, there's no benefit. You're watching this lecture. I want you to watch this lecture and don't do any revision after that. Just see the notes after that. You don't have to watch this video again and again. Right? Okay? Who is drawing it along with me? Let's see. Let's see. Let's do that. Okay? Let's do that. First thing is simple structure of glucose. How do you draw it? Draw 1, 2, 3, 4. Remember that CH2OH is always here. Now here, this is the cyclic structure of glucose. Draw 1. This is also CH2OH. Right? Acha, now here if you have, this is CHO. On the third carbon, I'll be writing the carbon here. This is 1, 2, 3, 4, 5. So don't cram anything, guys. I'm very bad in cramming things, okay? So that's why I just remember this structure. From there, I know how to form. And I'll tell you how easily I'll form this, right? So even this structure, I just remember this thing, that this is CHO, CH2OH, and on the third carbon, OH is on the left side. I just remember this thing, right? Frankly, I'm telling you, I don't remember all of those things. Just firstly, that's why I always draw third carbon firstly. If you cram things, you will end up, doing mistakes. But if you remember just 1-2 hints, you will not do any mistakes in the exam, right? This is OH, this is OH, this is OH, this is H, this is H, and this is H, right? Okay. Now, what you will do, draw the same thing, 1, 2, 3, 4. Now draw the carbon, that is the first carbon here, right? It is connected to the fifth one, right? Now everything else will be same here. I'll just draw, this is first carbon. This first carbon, this is the first carbon. So what I'm doing now, instead of taking this as the first carbon, I'm taking this one extra line here. That is my first carbon, right? Now I'll be drawing alpha carbon, alpha or beta, you can draw both of them, right? Okay. Chalo, let's draw alpha, right? Okay, let's draw alpha. Which one you want to draw, alpha or beta? I'll do one thing, I'll just do one thing here. This is as it is, just draw 1, 2, 3, 4, 5 and 6. Now write it same way. This here you had hydrogen. Here you had, wait a minute, hydrogen. This is HOH. So this also, if you like, ma'am, I don't want to see this thing here. How do you write it? Draw 5 lines here. 1, 2, 3, 4, 5. Right? This is the 6th. This is 1, 2, 3, 4, 5, 6 carbon. On the third carbon, OH is on the left side. Right? Second to fifth, you can write easily. But for first carbon, things are different. Okay, so that's why for first carbon, I'll be copy pasting this slide. I want to draw alpha and beta both. So what I'll do, let's draw alpha here. For alpha, OH is on the right side, this is H. For beta, what you have, OH is on the left side, this is H, that is beta. Okay, now all you have to do is draw the cyclic ring here. 1 2 3 4, place some space here. This is 1 2 3 4 and this is oxygen. See again, 1 2 3 4 and this is 5, right? Now what you have here, just write on fifth carbon you have CH2OH, because it is heavier, that's why always it will be on the upside, right? This is H. Rest of it, whatever is on the right side is on downside. Right side you have, on first you have OH, then you have OH, then you have H, then you have OH. And you can write the opposite counterparts here, right? And that is your answer, right? Okay. Achha, same thing you do for beta. What you have to do here, right? Just do this thing. In the end, you must know how to draw it as it is. Okay, ma'am, now I don't want to look at it. Ma'am, I don't want to get confused by looking at it. Ma'am, I want easy thing, ma'am. How do you make it easy? For glucose, draw now without looking at this. I'll tell you how to make this without looking at this. For glucose, alpha, beta both I'll tell you, right? Draw 6-membered ring, have oxygen and write 1 2 3 4 here. 1 2 3 4 and 5. Always remember on the fifth you will have CH2OH and H here in terms of glucose. Now remember on the third carbon, OH is on the left side. Left side means up. So OH is here. On the first carbon, though, I'll not talk about only because that defines alpha and beta. On second carbon, OH is on the right side, that means down. OH is on the right side, that means down. Right? Because I remember one thing, that in glucose, third carbon OH is on the left side. Ma'am, what about now? Ma'am, what about first carbon? Now, if I talk about alpha, then first carbon OH is on the right side, that means it will be down. If I talk about beta, OH will be, first carbon OH will be on the left side, that means up. And that's how you have your structures here. Okay? Yes? Tell me. You're already jotting down, that's amazing, right? Okay? That's how you write it, that's how you draw it. Simply do this, and trust me guys, if you know how to make this structure, you will have no problem in other parts, right? Okay, whatever I told you now, till now I told you just to make this, right? All this thing we have done. Now let's understand some of the definitions here. What is epimers, right? Epimers are diastereomers that differs in configuration at only one. Now diastereomers are what? They are non-superimposable mirror images. They are superimposable mirror images, right? Yes. Now if you see this here, this is CH2, this is capital D erythros, this is capital D therios, right? So they have different configuration only at one chiral carbon. So where they differ in the configuration, this is the configuration they are differing in. I'm so sorry, I told you wrong. They are not mirror images. No, that's what I was thinking. Enantiomers are non-superimposable mirror images. Diastereomers are not even mirror images, right? Okay, and superimposable mirror images are identical. So diastereomers are not even mirror images, not mirror images, right? Okay, not mirror images, right? So if you see, there will be, everything will be same, formula will be same, but what you will see, one chiral carbon will have opposite configuration that you will see. They are called as epimers. Epimers is a term used in case of sugars only. Two sugar molecules differ in some x number of carbon. Configuration is different. According to that, the epimer will be named. For example, you have C2 epimer. That means on the second carbon, the configuration is opposite, right? That means this carbon has opposite configuration. And you know what is the name here? This is called as glucose. And what is mannose? Mannose is same as glucose. It's just that when you draw the simple structure of glucose, right, open structure of glucose, on the second carbon you have OH on the right side in glucose, but in case of mannose, OH is on the left side, that is mannose, right? That is the difference in glucose and mannose, right? Okay, glucose and mannose, right? Then glucose, acha, mannose is not that important structure, but still you should remember because there is only one thing that is different. But glucose and galactose are very important. See, galactose you must know because that will be useful, right? When we will discuss further about these structures, that will be very useful. Now, can you see this over here? They are differing in which particular part? This is glucose, this is galactose. And as you can see this over here, they are differing in C4, 1, 2, 3, 4. This is the difference that 1, 2, 3, 4. This is the difference that they have, right? Here, C4 in glucose, it is on the right side, but in case of galactose, OH is on the left side. Now, guys, tell me, can you make the cyclic structure of galactose? Who will tell? Epimers means on one chiral carbon, their configuration is opposite. Like in these two, configuration is opposite. Like in these two, configuration is, everything else is same here. Everything else is same on just one chiral carbon, the configuration is opposite. So now tell me, will you be able to make the structure of galactose, right? Will you be able to do that? Acha, who will do that? The structure of galactose. Who will make the structure of galactose? Where should I make the structure of galactose? I'll just make this here. I'll not change this. I'll just change this thing. Okay? On the fourth carbon, everything else is same, guys. There is no difference. Or only on the fourth carbon, OH is on the left side. That means upwards. And that's it. If you have alpha galactose, this will be beta galactose. Beta galactose, right? That will be alpha galactose. I'll draw alpha only, right? I'll just copy paste this here and I'll form galactose here, right? Galactose, just remember C4 position is opposite, right? C4 position is opposite here. C4 position is opposite. Everything else is same as glucose. Everything else is same as glucose. C4 position is on the left side. So left side means what? Left side means here, right? Left side, and here it is left side means up. That is galactose, right? So two things, two major monomers, two major monosaccharides that you have in your syllabus, glucose and galactose, that are quite similar. So if you know the structure of glucose, you can easily make the structure of galactose as well, right? Then third one will be your fructose, right? We'll talk about that as well. Now let's talk about anomers, right? Anomers. You know, the most difficult part in this chapter is understanding these structures, because after that, once you understand that, it's going to be very smooth for you, right? This chapter looks like difficult, but once you do it and then you revise it, it will become really smooth for you, right? Because once you practice it, it's actually not a difficult chapter, right? I'm not saying this because I am your teacher and I'm for teachers, so they have done this multiple times, why they will find it difficult. I'm saying this when I was of your age, when I read this chapter for the first time, even I found this very difficult because I used to hate bio, right? I was never able to understand like these big names. I was not good in cramming. I only was good in understanding the concept and apply that concept. But then I understood it, right? With conceptual knowledge that, okay, there is some reason that this is so, that I don't have to cram the structures. I just have to understand the definitions here. You don't have to cram the structure, you just have to understand glucose carbon number 3 is on the left side, OH is on the left side, then there is CHO, then there is CH2, right? Pyranose ring is there. In galactose, everything else is same. C4, it is the opposite configuration, that's it, right? Okay, so anomers are, these are the stereoisomers which differs at same like single chiral center out of many and a ring chain tautomer of same open chain compound. So what exactly you have here? Two sugar that differs in configuration only on one, only on the carbon, that was the carbonyl carbon. In the open chain form is called as anomer. That means two compounds you have, they differ in configuration only on the carbon, that was carbonyl carbon in the open chain. Do you remember alpha and beta glucose? है ना, which carbon has different chain? Tell me. In alpha and beta, ma'am, is this also epimer? Ma'am, is this also epimer? This alpha and beta are definitely, we can say, anomers of each other. Can't we say that? They are anomers of each other. Can you tell me why? Because that particular carbon has difference in configuration. That was earlier the carbonyl carbon. Which carbon is different? Epimer, in epimer, I am not saying that this carbon should be having opposite configuration. But in case of anomer, I am specifying that which carbon should have opposite configuration. The carbon that was initially carbonyl carbon in the open chain, that should have opposite configuration. So these two are anomers of each other. And this is a very, very important line that we have here. Alpha and beta glucose are anomers. Anomers are epimers. Yes, because epimer says that any position, right, you have, any position you have, if you have difference in the configuration, that is epimer. Anomer specifies that that position should be that carbon which is initially the carbonyl carbon. So anomers are epimers, but all epimers are not anomers. So if you talk about this epimer here, if you talk about this epimer here, right, this is not anomer because this is epimer, this is not anomer. This is not anomer. Can you tell me why this is not anomer? Why this is not anomer? Because in this case, this carbonyl, this was not initially carbon, this is same only, this is not initially carbonyl carbon. If you talk about this thing here, is this anomer? This is also not anomer. These are just epimers. These are just epimers. Okay, everybody? Understood? Right, everyone? Tell me in the chat box. Right? Do let me know in the chat box if that thing is clear to all of you or not. Okay? Yes. Now let's talk about this. Epimers are diastereomers only. Diastereomer has a different definition. Epimer has a different definition. But epimers are a category of diastereomers only. Okay? Because if you have two epimers, they will never be mirror images of each other. That is why they are diastereomers. Right? Okay? Now let's talk about fructose. Fructose, that is having a ketone group. That is why it is called as ketohexose. Right? It is obtained along with the glucose by the hydrolysis of disaccharide, that is sucrose, because sucrose is made up of glucose and fructose. That is why on hydrolysis it gives you glucose and fructose. Natural monosaccharide found in fruits, honey, vegetables. It is pure form that is used as a sweetener. That's why what these doctors tell you, why they tell you not to drink juice, why it is not advised to drink juices, right? Why orange juice and all they avoid, you should avoid, because there will be sugar spike, and that sugar spike is not because of sucrose. Sucrose is not there in your fruits. In fruits, you have fructose. And it's not a bad sugar, it's a natural sugar. But God has given us that sugar with the fiber, with other things as well. So when you have juice, like let's say orange juice you have, right? You have pineapple juice. What exactly you are doing? You're just picking out sugar from that. You're picking out fructose and you're drinking the fructose. So that is eventually you are just having carbohydrates. You are not having fiber, right? So that is why that is not good for your body. It's not exactly not good for your body, but it's not like if you're eating it for the healthy, like I'm eating something healthy, this is what not you are doing, right? Okay, so better to have fruits, right? So that is my advice. Have fruits, because you know why I'm telling you. You are a science student, you should have logic behind what you're having, right? So that is why fruits, honey, vegetable, they all have fructose, which is a natural sugar. It's a natural sweetener, which is good for our body, right? Okay, it gives us good energy, right? And it's not like carbohydrates, ma'am, I want to be, ma'am, slim, trim, I don't want to have sugar. Sugar is important for you, but in what form you eat it, in what quantity you eat it. You should always have sugar with fiber and all, right? I have too much interest in nutrition right? So I'll just avoid this now, right? Okay, as OH in C5 is on the right, so what exactly happens in fructose? Now, can you see this negative sign here? Who will tell me why this negative sign? Because fructose is always levorotatory, right? Fructose is always levorotatory, right? Levorotatory. That means it will be L, that is negative, right? It is going to be levorotatory. Now, let's talk about as OH on C5. You have 1, 2, 3, 4, 5. O on C5 is on right. It is a D sugar. Why it is capital D? Glucose is also capital D because the last chiral carbon. What defines capital D and capital L? Capital D means the last chiral carbon should be, again I am repeating, last chiral carbon should be on the right side, that is capital D. Last chiral carbon on the left side, that is capital L. Small d is rotation, that has no link here, right? So here glucose is also capital D, fructose is also capital D, galactose is also capital D. All of these are capital D only. But if you talk about glucose, that is dextrorotatory, fructose is levorotatory, right? So if you have this here, that is a D sugar. So what exactly you have here? You have 6 carbons here. In the first carbon there is CH2OH, on the last you have CH2OH. Here you have C double bond O on the second carbon, that is ketone. Now remember one thing, just like glucose on the third carbon is on the OH, rest of them is not on the OH. Simple. Just remember one thing, third carbon OH is on the left side. That's it. Rest of the things we know that for a ketone, this will CH2OH, CH2OH, and this would be C double bond O. You left with 3 carbon, 1, 2, 3. On the third carbon, OH is on the left side. Others, it should be on the right side. Right? Okay. Yes. Okay. Yes. Glucose, galactose, mannose are aldohexose sugar. This we have seen. Glucose and galactose are epimer. Glucose and mannose are epimers. So they are having aldehyde. So they will be called as aldohexose. But fructose is a ketohexose sugar. Okay. Fructose is a ketohexose sugar. Right. Okay. So this is the structure of fructose you have, as we have already studied it. Now tell me, wait a minute. Abhi to we are about to see the structures and all of this one. But JEE Mains 2021 question, and that's such a simple question, right? Okay, you will see this. Fructose is an example of pyranose, ketohexose, aldohexose, and heptose. So definitely it is not pyranose. I'll tell you why it is not pyranose. So what exactly happens now? Here you have connection of carbonyl carbon with the fifth carbon. So if you see 1, 2, 3, 4, Wait a minute. 1, 2, 3, 4. This will be on the fifth carbon, na? 5-membered ring it will have, this kind of. One oxygen also will be there. I forgot. Like, my bad, guys. This oxygen also will be here, na? This oxygen also will be linked. So this is 1, 2, 3, 4, and this fifth is oxygen. So it is a 5-membered ring that you will have. That is furanose ring. That is not pyranose ring. Okay. So fructose has F for fructose, F for furanose ring. So pyranose ring is definitely not correct here. Ketohexose is correct. It has ketone. It is 6 carbon. Aldohexose is not correct. Heptose is definitely not correct. So answer will be B is the correct answer. And that is your JEPYQ. That is such a simple question. I am not making it myself. This is a question that has been asked. And you tell me that's such a simple question, isn't it? Right? So, unlike glucose and fructose, practically it seems that 6-membered rings are formed in very small quantities and relative formation of 5-membered rings are more frequent. Right? So, we'll talk about, it's not like it does not exist in 6-membered ring, but we'll talk about 5-membered ring only. Right? So, firstly, let's draw the alpha structure. Firstly, let's draw this structure here. Right? Okay? Let's draw this structure. How it is formed. Let's see that everybody, right? How that is formed. Let's see. Same thing I'll do here that I did before, right? Tell me what we did before. We had this one. So I'll not draw it like this. I'll just simply draw it like this. This is CH2OH. 2 carbons are already occupied, CH2OH. And here you have C double bond O, right? This is 1, 2, 3, 4, 5, 6. So here on the third, 1, 2, 3, third carbon, you have OH on the left side, others are on the right side. Okay? This is what you have. This is how you remember this. Now to convert it into cycling ring, just like what we did before, what is going to happen? I'll just firstly write which is first, second, third, fourth. 1, this is second, this is third, fourth, fifth, and this is sixth. So connect the carbonyl carbon with the fifth carbon. Okay, so this is the carbonyl carbon. Carbon is connected to the fifth carbon, fifth oxygen, I would say. Fifth, this you have to connect. Okay. Now what will happen here? See this? I have connected. Now I will shift this particular hydrogen. Achha, before shifting also you should know that this bond will shift here. Here you will have O negative, right? Here you will have the formation of O negative, right? So write it down. You will have O negative here. Once you have O negative, this hydrogen will shift here, which makes it OH here, right? Which will make it OH here. Now that OH we don't know whether that will be on the right side or left side, because see earlier you had here C double bond OH here. This was already there, right? Now you have OH and H here. This particular thing we don't know whether this will have on the second carbon. We don't know whether OH will be on the left side or right hand side. Accordingly, you will have alpha and beta, right? So if you see this here, this is the cyclic structure. Wait a minute. 1, 2, 3, 4, right? Yes. Okay. 1, 2, 3. No. This hydrogen will not be there, na? C double bond 1, 2. No. Hydrogen to will not be there. My bad. Hydrogen will not be there. Why? Because already the tetravalency is completed. Then what hydrogen will do here? So already it was what? Already it was C double bond O. Okay, this was already there. 4 bonds were already completed. So hydrogen will not be there, right? Okay. Now what you have here on the Second carbon, you have OH and CH2OH. Now we don't know whether OH will be on the left side or OH will be on the right side. That is the confusing part that we have. Okay, we don't know whether OH will be on the left side. This is the whole part. We don't know OH will be on the left side or the right side. Accordingly, we'll decide it. Right? This is for the second carbon. Third carbon it is fixed, fourth carbon it is fixed, and fifth carbon now has CH2OH and this OH O ring here. That is your cyclic structure. And when you convert this cyclic structure to furanose ring, you just draw a 5-membered ring. Now write down, this is first, second, third, fourth, fifth, sixth. So on the second carbon, you will just start it with second carbon, second, third, fourth, fifth, right? And that will be your sixth, right? And this will be your sixth carbon, right? This will be your sixth carbon, right? Now, third carbon we know OH is on the left side, so it is a fourth also we know. Fifth we know CH2OH will always be on the upside. But what about this second carbon? In second carbon, if I say that this OH is on the, this means OH up means OH was on the left side. Okay. When OH is on the left side, that means we are talking about beta fructose. Okay. And if I say in the same situation, if I make alpha, then I'll write it opposite. Here. Let's see. How do you write it? Right? That will be alpha. Alpha is, you have OH on the right side, that means down, and this is CH2OH. Here, OH on the right side, this is CH2OH. So this is your alpha fructose. Okay? Usually you will see beta fructose only. For you, so you will see beta fructose only, but you should know that where you have the difference of alpha and beta fructose. Got it, everybody? So that is the difference of alpha and beta fructose. In alpha, you have OH on the, wait a minute. OH is on the, this, we have done this, wait a minute. Furanose ring, this is alpha, na? OH is on the, oops, I have written the opposite. Wait a minute, I'll just delete this part. Oh, I have written the opposite. For alpha here, OH should be on the, heavier part should be on the right side, yes. More molecular weight should be on the right side. So here in case of fructose, more molecular weight is of CH2OH. That is on the left side, that means this will be beta. More molecular weight should be on the left side, so this will be beta. In case of glucose, hydrogen and OH having more molecular weight, but here CH2OH is having more molecular weight. So more molecular weight should be on the right side, okay? So in this case, if you see, this is going to be alpha, okay? This is going to be alpha here. Right, everybody? Do let me know. Yes. So here, okay? नहीं, इसका मतलब I have written before, right? I am little confused here in alpha and beta weight. Alpha OH. I'll just delete this, okay? Just give me a second. I'll just delete this itself, right? So I'll just write this again. So here, OH is on the right side, right? That means it is down. So it should be, if I say this is alpha, right? This is alpha, right? And if I say OH is on the left side, then that is beta. Okay? And that is, if you see this here, alpha OH is on the downside. Yes, okay. Okay. I have drawn it before only. First, I thought this is because there is some cases where molecular weight we see, right? But here we don't see the molecular weight. Okay. So that is the definition of alpha and beta, just like same in glucose. That is my bad. It is same as glucose, right? Okay. And this also you don't have to do. That is nothing but what is furan and all, right? This is just the theory part. So I have deleted it, right? This also you don't need to do, right? Okay. Now let's talk about some questions here. That is JEE Mains 2023 question, and that is also quite simple. They are saying correct represented six-membered ring of pyranose form the following sugar X. What is this sugar X? This is CH2OH. This is CHO. If you see this here, can you name this sugar, everybody? Here, first carbon alpha, first carbon OH is on the left side. Left side means that is beta. Other thing is that 1, 2, 3, third carbon is on the left side. Then rest of it is on, that means this is beta glucose that we are talking about. Now you have to convert this into pyranose ring. So what you will have here, this will be the first carbon, this will be converted, this will be second, third, fourth and fifth. This carbon will have oxygen with the first carbon here. Wait a minute. It will have, with this carbon, it will have oxygen here. So it will be like this, right? And here on the beta means, but this is not beta, na? Alpha, beta, how I can tell about it? My bad, huh? Why I'm doing these silly mistakes, guys? I think I need break. Wait a minute. We can't say this is beta. Here first carbon is different. That means this is actually, right? This is actually not an epimer. This is actually an epimer, right? So what you will do here, this is second, this is third, this is fourth, this is fifth, this is sixth. First carbon you can draw anywhere, that we can't justify from this thing what will be the first carbon. We can definitely say second carbon OH should be on the second and third carbon, OH should be on the left side, that means upside. So second and third, first we don't know. This is 1, 2, first we don't know. Second and third it should be up. And here it is possible. Here second is up but third is not up. So this is not possible. Second and third should be up. This is not possible. Here second and third should be up. This is not possible. So one thing, first I don't know. But second and third should be on the upside. And fourth should be on the downside. That is clear. And fifth also CH2OH will be on the upside. That means this is the carbon. And if you see this here, in the end, the structure that you are having is B because everything else is eliminated here. And this is the first carbon. If you see, after making OH is on the downside, that means on the right side, that means this structure is alpha structure here. So answer will be B is the correct answer. Huh. Right? Same side, second and third are same? No. Huh, second and third are same side. Huh. Okay, same side that means upside that should be there. You just have to see this. And that is your JEE 2023 question, which was an easy question only. Okay? Now let's talk about sucrose. Now the best part about JEE is that you don't have to draw the structures in the exam. You just have to know that how glucose, galactose, fructose, these structure you draw, and polysaccharides, oligosaccharides will be very easy for you. You just have to remember the linkages here, that's it. Okay? Right, everybody? Tell me. Clear? Done, everyone? Okay? Chalo. Now sucrose, remember the glycosidic linkages that they have. Glycosidic linkages. What is glycosidic linkages? So what exactly happens? Let's say this is glucose, this is fructose. This is glucose, this is 1, 2, 3, 4, 5. and this is 6. Fructose is, this is 1, 2, 3, 4, 5 and this is 6. Okay? So you can see what are the linkages that are connected here. The linkage of sucrose is carbon 1 of glucose and carbon 2 of fructose. That means this carbon of fructose. So what you will see here, right? What you will see here, you can also draw it in the opposite side, opposite manner also you can draw it, right? So what you will see, this is the carbon 2, this is the carbon 1. When they are connected, what you will see that here water will be eliminated. Whenever you have OH on that carbon and water is eliminated, right? So here what will happen, let's say this hydrogen and this OH that will leave and they will get connected to each other. So what they will form, this is O, this is again carbon, this is O, this is again carbon, and that is formed after carbon. Now better way to draw this structure is lengthwise. Okay, better ways to draw the structure is lengthwise, but this way also you can understand this. Tell me if you want me to draw the structure lengthwise, right? If you want me to draw the structure lengthwise, I'll do that, right? But as such structured drawing, you don't have to remember how it is drawn and all, right? You just have to remember this thing here. I'll just draw the structure lengthwise, how it is actually. Glycosidic linkages, this ROR ether-like bond that you have, that is called as glycosidic linkage. Okay, this ether-like bond that you have, that is called as glycosidic linkage. So what you have here, so I'll just draw the structure here in front of you only. So what you have, see how glucose is formed. Glucose is pyranose ring. Okay, I will not draw the other structure. I'll just draw C1 and C2 position. This is C1 and this is C2. I'll draw only these two, right? So this is C1, this is oxygen, and C1 is having one hydrogen because this is alpha glucose. So OH is here, and beta fructose. Now this also you have to remember that alpha glucose and beta fructose are connected here. So in case of beta fructose, just remember, right? We know that it has this kind of structure where this is the second carbon, first carbon is this. For beta fructose, OH is on the upside. Okay, now what you will have, water will be eliminated. So eliminate the water here, water will be eliminated. So O, H and O, this will be eliminated, and what kind of linkages is formed? This O linkage is formed here. This is called as glycosidic linkage. Okay, rest of this so you can draw yourself also, right? I am not drawing this, it is just a waste of time, right? That I don't want to do, right? So you know that what will be, because other carbon does not have any role here, only because C1 and C2, this is the C1, this is the C1 of alpha glucose, and this is the C2 because this is the 1. So this is the C2 of beta fructose. They are connected to give you sucrose. Okay, so just remember the glycosidic linkages between 5 fructose, ma'am. 5 glucose kya? Nahi, fifth carbon it is not connected to. Okay, it is connected. You can see it is not connected like this. Okay, it's just that they have given you here this positions also they have changed. It's not like these two things are connected, these two are connected. The linkages are between alpha D glucose, that is the C1 carbon of alpha D glucose, and C4 carbon of beta D fructose. Okay, that you should remember. Okay, tell me everybody. Yes, everybody, tell me. No, beta, that's why I have written C1 and C2. Okay, C1 and C2. There is no C5 here, C1 and C2. Okay, this is also, you can erase this. ठीक है, that's why I drew this structure for you. You can see this here, right? Okay, so I'll write the full structure here. This is CH2OH, this is H, this is H, OH, OH, H, H, OH, right? This is CH2OH, this is H, H, OH, right? OH, and this is H, right? It is between C1 and C2. Okay. बेटा how, देखो बेटा, this is the structure of fructose, ठीक है? This is 1, this is 2, right? 3, 4, 5. Whenever you have hydrogen here, right, that is your fifth carbon. The carbon, second carbon has OH and CH2OH. Haven't I written it like this? Tell me. You know, one student say, everyone follows that. Tell me. This is first and this is second carbon. Second carbon, and how can fifth carbon lose water? Fifth carbon does not have hydrogen. If you see this here, right, this is no, right, this is, I will erase this, okay? This is not correct here, right? This is a mistake that is there, right? Here if I draw, fifth carbon is not connected to this one, okay? This is how you draw it. See this one that I have shown you there, okay? Wait a minute. Where in NCRT it is written? Sabrinath, where in NCRT it is written C5? C5, so how it is possible, na? C5 तो does not have OH only, right? Then how it is possible with C5? Hmm? C1 and C1 of alpha D glucose, C2 of beta D fructose gives you sucrose. Okay? ठीक है जी? Tell me. Can you please check NCRT? Wait a minute. Let me check that. Why it is written. Beta NCRT, so I'll see it. Wait a minute. Fifth number. Which page number you're talking about? Which, are you sure this isn't written in NCRT? Wait a minute. Chalo, we'll see this. I'll see it in the break. Okay. I don't know where in NCRT it is written, but it is C1 and C5 only. And even this structure is not correct, right? Even this structure, I'll just rewrite this structure. This is not correct. Okay. Even this structure is not correct. Okay, so I'll just delete this. C1 and C2 of what we do, right? That is the linkage. C1 of alpha D and C2 of beta. You just numbered it differently. I don't know if you're numbering it like this, right? In NCRT, if it is written, they must have, it's not possible, na? With fifth, so the way I have numbered it, it's not possible. Even I have numbered it here also. If you see, na, now, if you see this here, this is fructose, right? This is beta fructose. Now, in your NCRT, I don't know if it is written numbered like that or not. According to me, it should be numbered 1, 2, 3, 4, 5, and 6. That is a correct numbering sequence, right? Okay. And for that C2 linkage, you have to remember, right? If you're numbering it like 1, 2, 3, 4, that is not a correct way of numbering, right? So number it this way, right? And remember these glycosidic linkages. If you say, ma'am, I want to remember C1 and C5, if in the exam they ask you which of the following is the glycosidic linkages of sucrose, because you are numbering it yourself, see, you're numbering it oppositely. So you will write it C1 of alpha and C5 of beta. That is a correct thing. That is an incorrect thing. Glucose, alpha glucose will have C1 and beta fructose. Numbering also do it this way only. If you're numbering it oppositely, you're doing it wrong. Okay? Understood? That's how sucrose will look like. Okay? Tell me everybody. Understood? Ma'am, the structure on the slide. That's why I deleted it only. I think that was maybe some glitch was there. So that is not correct structure. That's why I drew it myself. This is the correct structure. Okay, this is the correct structure. Acha, now see this over here. See this over here, what you have. See this over here, what you have. This sucrose is non-reducing sugar. Now that also I'll talk about why, what is reducing, what is non-reducing. Right? Okay? Yes? Chalo. Now, sucrose is dextrorotatory, but after hydrolysis gives dextrorotatory glucose and levorotatory fructose. Sucrose is dextro. Now, this is also another important point, that sucrose is dextro, right? But glucose is dextro and it gives levorotatory fructose. Hydrolysis of sucrose brings about a change in the sign of rotation, dextro to levo, and the product is named as invert sugar. That is called as inversion of sugar. So this is sucrose. That is going to give you, let me see if it is written here. No, that is going to give you, sucrose is going to give you glucose and fructose, right? So here this is dextro, this is levo, and the sign changes from positive to negative. That means the levo rotation is more as compared to dextro rotation. Okay? Yes, everybody? Understood? Yes. Now let's see this one. Linkage is between C1 of galactose and C4 of glucose, right? So let's discuss that. This is lactose, and I'll see. Don't worry, after the break, I'm gonna go. Don't worry about that. I'll see what structure is drawn in your NCRT, right? And after the break, I'll tell you that which one you should follow, right? Okay. Let's see lactose, right? Because if I don't see the structure, maybe there is some other point written there and you have not, give importance to that. So I'll see. Then definitely NCRT is the god. You'll have to follow whatever is written in NCRT. But let me just see that. After that only I can tell you, right? Lactose is beta D galactose and beta D glucose you have, and the linkages are C1 and C4 linkages, right? The linkages are C1 and C4 linkages. If you see this here, right? This is C1 and C4 linkages, what you have. And here what you will have, this is C1, this is C4, this is a direct linkage. Here you will have OH, here you will have OH. And what is happening? Water is eliminated, and this is the structure that is getting formed, right? Okay. Just remember the linkages: C1 of galactose, C4 of glucose, right? It is more commonly used as milk sugar, right? And it is beta D galactose and beta D glucose it is made up of. Free aldehyde group may be produced at C1 glucose, hence it is reducing. Now, very important thing is, what are reducing and what are non-reducing, right? So let's see maltose as well, then I'll tell you what is the thing about reducing and non-reducing. If you talk about maltose, that is made by, this is two glucose units that is made by, and if you see they both are alpha, 2 alpha, and this is between C1 and C4 of alpha, C1 and C4 of alpha D glucose. That is the glycosidic linkage here. Okay, C1 and C4 of alpha D glucose. So this is 1, 2, 3, 4, 5, 6. This is also 1, 2, 3, 4, 5, 6. Okay, so here what you will have the elimination of water, and that's how a glycosidic linkage is formed between C1 and C4 of alpha D glucose. Right, everybody? Yes. Right? Okay, tell me. Understood this? Right? Done, everyone? Chalo. Now, let's see glycosidic. This I have already told you, C1 and C4 of alpha D. Now, let's talk about reducing, non-reducing. Ma'am, what is this reducing, non-reducing thing you are talking about? See, if I talk about reducing sugar, right? Reducing simply means that it is going to reduce Tollens reagent. Now, if you remember, Tollens reagent will be reduced by, what is Tollens reagent? Let me just, because I have reducing, non-reducing sugar, na? Chalo, it is very far away. Where should I write it? It is, I have written reducing, non-reducing as well. It is quite far away where I have written. It is over here that I have written it. Right? I'll just pick it there. Reducing and non-reducing. I was thinking to teach you after that, but I think now it is the best time to teach you that, because again and again it is getting repeated. So let's see. Achha, reducing sugar will be which reduced carbohydrates that can reduce Tollens reagent and Felling solution. Just if you remember, in Tollens reagent you have aldehyde. It should be aldehyde. Ketone does not give this test. Or do you remember a ketone that is alpha hydroxy ketone? That can also give this test. So they both give you positive test for Tollens and Felling solution. This is positive test, but ketone does not give this test. Ketone will not give this test. Now what we can see, ma'am, if ketone does not give the test, then how can you say monosaccharides are reducing sugars? Let's talk about that. Okay? Why all monosaccharides are reducing sugar? Okay, in monosaccharides, see what you have. You have glucose, right? If I talk about glucose, this is glucose, right? This is the structure of glucose, alpha, beta, whatsoever you talk about. This is the structure of glucose. This is the cyclic structure of glucose, right? Even if you talk about simple glucose here, open structure only if you talk about, this is CH2 group. That's why it is giving you positive test of Tollens, because aldehyde give this test. This structure is made from aldehyde only, right? So if aldehyde was present, that means it is going to give you positive test of Tollens and Felling. That means glucose and galactose, that is for sure they are going to give you a positive test because they have aldehydes. That is clear. Why we have glucose and galactose giving positive test of Tollens and Felling? Why they are reducing? Now the question is about, ma'am, but ketone does not give this test, and you are saying fructose gives this test. Ma'am, how can you say that? Isn't it? Ma'am, how can you say that fructose gives this test? Now I told you that alpha beta, if you have a ketone that is having alpha hydroxy, so alpha hydroxy ketone, give positive test, give positive Tollens and Felling test, So that means, can I say this is ketone and here on the alpha position you have hydroxy? That's why this is giving you, okay? So that's why we have written directly that all monosaccharides are giving you a positive test. Then, ma'am, what about disaccharides? In disaccharides, it's a very famous question that sucrose is non-reducing, maltose and lactose is reducing. The answer lies in their structure. Let's see why. Firstly, let's see why lactose and maltose, why they are reducing. So lactose, if you see, two are having glycosidic linkages. Can you see this C1 is free here? Right? Can you see this C1 is free here? Right? So when you have an oxidizing agent, this easily can be converted to CH2. Right? Because this is free OH. It can be converted to CH2. And that is the reason what you will see, this is giving you positive test here. Right? Similarly, in case of maltose also, you will see there will be free OH here, and here also you have the free OH here as well, right? In these two cases as well, you have free OH on the anomeric position, right? So on the anomeric position, if you have the free OH, anomeric means the one that was carbonyl before. So this carbon was carbonyl before, it has OH. That means this carbon, can you relate? This carbon was initially a carbonyl. If I say this is a glucose, it was initially CHO only. In the open chain, it was CHO only. From CHO, we converted it to COH. Do you remember? That was the anomeric carbon, right? So that means it is free now. In these two cases, so it is free. Now, this is a whole point of the structure, but in this case, anomeric carbon are not free. Why? That's why I was telling you that whatever is written in NCERT, I'll have to check, but always according to this numbering that I have done, it is C1 and C2, and numbering usually is C2 only, right? Even I am shocked that why it is opposite in NCERT. I'll have to see that, right? This is first and second. Now this is the anomeric position. This is the anomeric. Can you see anomeric position is not having OH. In this structure, anomeric position does not have OH. Now when anomeric position does not have OH, then it will not be converted to CHO, and that is why it does not give the test. Tell me, understand everyone? Anomeric carbon does not have OH. Does not have OH. So it is non-reducing. That's why it is non-reducing sugar. Right? Okay? Here anomeric has, here if you can see, this is anomeric and this is anomeric. This anomeric does not have, but this anomeric has. Right? This is not anomeric. Right? Here this is anomeric and this is anomeric. Here this anomeric has OH, so that's why it is reducing. Right? Okay, chalo. Now let's move ahead. Right, Bacha, tell me any problem here. Let's do some questions now. Which of the following glycosidic linkages between galactose and glucose is present in lactose? 2021 question it is. Which of the following glycosidic linkages between glucose and between galactose and this is present? Lactose has the presence of which glycosidic linkages? Right? Glycose has the presence of which glycosidic linkages between glucose and galactose? C1 and which one? Tell me. C1 and C4. Very good. So answer is C1 and C4 of C1 of galactose and C4 of glucose is the correct thing. Wait a minute. This is the lactose, right? And here you can see this was galactose, C1 of galactose, and C4 of glucose is the linkage here. Okay, C1 of galactose, C4 of glucose. Right? Then next question, again directly based on your glycosidic linkages. sucrose, lactose and maltose are given to you. They have given you glycosidic linkages. You don't have to tell C1, C2. You just have to tell from where it was formed. Sucrose is made up of glucose and fructose, right? So it is one is A is 2. A is 2 only in this case. So answer will be D is the correct answer. So very simple and direct. So that's why I'm telling you, you should don't learn the structures and all for your JE, right? Just remember the glycosidic linkages. Okay? Obviously, you should know the structure of glucose, fructose, and galactose. These three cyclic structures you should definitely know. But structure of, ma'am, how do I draw? Sucrose, maltose, galactose, just remember the glycosidic linkages, and if you know, you can easily answer, right? Okay. Then let's talk about hydrolysis. After hydrolysis, they will give the same monosaccharide from where they were formed. Like sucrose is made up of glucose and fructose. Maltose is made up of glucose and glucose. And lactose is made up of galactose and glucose. Galactose and glucose, right? So that's how they will give you the hydrolysis answer, right? Now, if I talk about cane sugar I told you, right? Inversion of cane sugar, sucrose on hydrolysis gives you glucose and fructose, right? But this is dextrorotatory, this is dextrorotatory, this is levorotatory. The levo-rotation is so high, you can see this here. This rotation is plus 66, this is plus 52. But the levo-rotation here is very high, that is 92. So that is why it is in the end, in the overall, it is getting converted to dextro to levo, because here this it's not like the amount of. Now this question was also asked in assertion reasoning. They can ask you why it is called as inversion. In sucrose there is inversion of sugar. That is true. Reason was, which now they had given one reason, right? The reason was that the levo-rotation is more, right? Is that the correct answer? Or the number of fructose molecule formed is more? No. Levo-rotation is more. That is why dextro to levo. Even though here also dextro you have, but this rotation is more. That is why overall effect is dextro to levo, because levo-rotation is more. It's not because fructose is formed in more amount. They are formed in equal amount only, right? Okay. Now, next question is compound A gives D-galactose and D-glucose on hydrolysis. The compound A is amylose, sucrose, maltose, lactose. Which is the compound A? Tell me, everybody. Yes. In chemical kinetics also as an example, right? So you have D-galactose and D-glucose. Which is that compound that give you D-galactose and D-glucose? Sucrose, lactose, maltose. Which is that one? Very good. That is Nini. That will be D-galactose and glucose. Now that will be lactose. Okay, maltose is made up of beta glucose. Sucrose is made up of glucose and fructose, right? So answer will be D is the correct answer here, right? Okay. Now let's talk about polysaccharides. Yes, everybody, do let me know in the chat box if that is clear. Okay. Yes. Beta, in hydrolysis, on water, on addition of water, the molecule breaks. Lysis means breakage. So here they are breaking, that's why it is not hydration, this is hydrolysis. Okay. So let's talk about polysaccharide here. So just remember the linkages here, right? It contains large number of monosaccharides. Not here you were having just 2 monosaccharides connected. Here you have large number of monosaccharides unit joined together by glycosidic linkages. So you have starch, that is amylose, and 2 type of starch you have. One is amylose, one is amylopectin. So amylose has which linkages? Alpha D glucose units are connected by C1 and C4 linkages, glycosidic linkages. So isn't it same like maltose, right? Can you see in maltose what was there? In maltose also you had C1 and C4 linkages of alpha D glucose, right? Okay, you have alpha D glucose, its C1 and C4 linkages were there. But in this case, if you see, right, in this case, there are also alpha D linkages of C1 and C4. But here, not one glycosidic, there are so many, n number of glycosidic linkages are there, right? Okay, that's why this is a polysaccharide, that is amylose. And what is amylopectin? Here also you have C1, C4 linkages, but along with C1, C4 linkages, you also have C1, C6 glycosidic linkages. That is why amylopectin is also branched. So here if you see, this is C1, C4 linkage. This is 1, 2, 3, 4, 5, 6. This is C1, C6 linkage. This is again C1, C4 linkage. That is why it is not a straight chain. It is having branches here, right? Okay, so that is the difference in amylose and amylopectin. The difference they can ask you, what is the difference in amylose and amylopectin? Amylose has C1, C4 alpha D. Amylopectin has C1, C4 and C1, C6. Both the linkages are there, right? Carbohydrates are stored in the animal body as glycogen. So all the carbohydrates, right, we are eating, that is stored as glycogen, right? Then known as animal starch because its structure is similar to amylopectin and is rather more highly branched. Structure is same, you have C1, C4 and C1, C6 linkages, but in glycogen it is more heavily branched, right? Present in liver, muscles, brain. When the body needs glucose, enzymes break the glycogen down to glucose, right? So what exactly happens? This glycogen that is stored in our body, you must have felt this like you must have felt this one thing, that whenever there is like you don't eat anything, now person if he is not eating for like 2 days or so, they can still survive because of this glycogen, because it is breaking. Once glycogen is also not there in the body and the person is not eating, then eventually they will die. So how this is by evolution, your body, is made like that when there was less food available, right? So your body has made it through evolution that whenever you eat something, it is stored, right, as a glycogen, right? So now that's why it is like advised that you must fast, right? You must fast, not now because you have your exam right now. When you must fast, sometimes you should also detoxify yourself. It's not that one day fast you will die only, right? Now we know that in fasting what we do, we eat pakodes and all, right? We are like, today is this fast, let's eat something really interesting, we eat fried food, but actually that's not fasting. Fasting is like you should detoxify your body, because your body is not going to die. You have glycogen that is going to break down and give you glucose, but definitely not that much fasting, right? Okay, so now that is having C1, C4 and C1, C6 linkages, but that is more, I'll just write this here as well, right? It has C1, C4 and C1, C6 linkages, glycan of alpha D glucose. See, amylose, amylopectin and glycogen all have alpha D glucose. Amylose have C1, C4. Amylopectin and glycogen has C1, C4 and C1, C6. Glycogen also has the same as amylopectin, but glycogen is more complex. It is having more branching. That is the difference, okay? Now, if you see this here, what is cellulose? Here also you have glucose, but here in this case you have beta glucose, right? It occurs exclusively in plants and most abundant organic substance in plant kingdom, right? It exists in plants, right? Then it is predominant constituent of a cell wall of plant cells. Cellulose, I don't know if there is any bio students or not. Even if you're not a bio student, cellulose, cell wall, so we have studied in 9th class as well, right? So cellulose is a straight chain, right? You remember cellulose, cell wall, right? So that is a straight chain composed of only beta D glucose. It only has beta D glucose unit, which are joined by C1 of one glucose and C4 of other glucose. So what you have, Just remember this thing, C1, C4, glycosidic linkages of beta glucose. Okay. Now I would advise all of you to do one thing. Write down all the linkages. Write down, not right now, after the class, write down the linkages of sucrose. Just remember the linkages of sucrose, maltose, galactose, sucrose, maltose, lactose, and amylopectin, amylose, glycogen, and cellulose, right? Linkages, very simple question will be asked based on linkages, and hardly 1 to 2 seconds you can answer it. Trust me, save your time from these kind of questions. Right now you will find it, these kind of chapters, when you're doing it, you find it very irritating, like why I'm doing this. Even inorganic chemistry, block chemistry, when you do it, you find it very irritating, so much cramming is there. But these are the things that help you, because these things does not require any problem solving in the exam. There you know the answer or you don't know the answer. There is no possibility of wasting your time in the exam. Either you will do the answer correctly or you will leave the answer within 1 second. So that is not going to waste your time, right? And if you do the answer, these kind of questions, so you will do within like 2 to 3 seconds itself, right? So that is there. Now, chemical reaction of glucose, most of it we have done only, but still some reactions will be new to you as well. So after this, I'm going to give you break. After completing carbohydrates, I'm going to give you break. Right? Okay. Yes, everybody. Chalo. Now, if you have glucose, let's talk about Tollens reagent. Tollens reagent, what it is going to give you? Tollens reagent will give you gluconic acid, that is gluconic acid. Felling solution will give you gluconic, Br2 water will give you gluconic acid. So remember, glucose with Tollens, Felling or Br2 water, bromine water is going to give you gluconic acid. That has just replaced CHO with COH. That is your gluconic acid. If you have concentrated HNO3, it's a strong oxidizing agent, very strong. So that is why this CHO and CH2OH both are getting converted to, both will be getting converted to COOH, right? Okay. Then there is, if you talk about glucose, when you have red phosphorus HI, it is going to give you hexane. We discussed it before as well. Now, if you have sodium amalgam, this is a new reaction for you. If you have sodium amalgam, this we have not discussed before. Sodium amalgam, in this case, what will happen? This is a reducing agent. So this will convert this CHO to CH2OH, and that is sorbitol is formed. That is called as sorbitol. So you will just write it here. This is a reducing agent. It will reduce CHO to CH2. Till now we were discussing oxidizing agents, Br2 Tollens, then you have Felling, right? Then you have concentrated HNO3, all are oxidizing. This one is reducing. Then you have NH4OH, that we know it will form oxime. We have done this before as well. This also we have done before as well, right? Okay. This one, if you have anhydride or you have this that means acetyl group you should have, AC you should have. So what will happen? This and this hydrogen will be replaced by AC. So it will be OAC4, this will be OAC, right? This also we have done before as well, right? This is this one thing. This now you will see this is quite different actually, because what we expect and what is there, that is different, है ना? Based on reactions, then we will see the questions, right? Okay, see this thing now, see this thing now, what you have here. In this case, what we expected, C double bond OH, ma'am, okay, that we know, this oxygen will leave here, right? And ma'am, here this will be H2 will leave, and this will be double bond N. This is NH, this is pH. That is there, that is correct. But ma'am, why this also gets converted? Because what happens here, I'll just tell you. In this case, you have CH. What exactly happened? This OH is also converted to this double bond N, same thing, NNH and PH. Okay? Same thing will happen here, right? Same thing is going to take place, right? Okay. So firstly, H positive will leave, this will be connected here, this will have a double bond here, right? Once you have a double bond, then after that, oxygen and this hydrogen will leave, then you have a nitrogen here. Okay, so firstly, what will happen? This is connected to double bond. Okay. Then after that, this double bond just in the same situation, this will be N, H2 will go, this will be N, then NH, then PH. Okay, just convert the OH to double bond O first, right? And that is why this question, this particular reaction is important, right? Okay, so two new reactions we have done. Old reactions, we say I will not want to delete it because in the end you have all the reactions in one plate. Achha, now let's see this question if you can answer this. JEE means 2019 question that says column 1 and column 2 you have here, right? See one thing. If you have glucose and HI, this is glucose and Br2 water, this is glucose and acetic anhydride and HNO3. With HI, it is going to give you hexane. So A is 4, right? A is 4, A is 4. This is eliminated, this is eliminated. Then glucose with Br2 water is going to give you gluconic acid. So B is 1, B is 1. So you have your answer. A is the correct answer, but still we will see rest. Acetic anhydride is going to give you pentaacetate. So it is 2. Yes. And HNO3 is going to give you saccharic acid. That is D. So answer is A is the correct answer. Okay. Right. Okay. These are all your PYQs. You can see for yourself. They are very direct question that they ask you. Okay. Okay. Tell me everybody. Is that clear? Achha, shall we have a break at 9 p.m.? 9 p.m. Tell me. Tell me. Good to go? So carbohydrate was the major part here. You can see 80 slides for carbohydrates. See? So rest of the things are like it's not like too much. You will have to see even now just to make you understand. I gave you this is detailed biomolecules I'm teaching you, right? When I'll do the revision, you will see hardly these 80 slides. I'll do it in 8 pages, right? So it's not like 80 slides you have to remember. You just have to remember some 4 or 5 pages, and I will show you when we will do the revision. If you want revision of organic chemistry, do let me know in the comment section, right? Okay. Yes. Okay, 9 p.m. okay na? 9 p.m. we'll have the break. Wait a minute. Okay. So 9 p.m. we'll have the break. Before that, let's complete 100, 120 slides, right? So that we are left with very less part. I want today to lecture get completed by 12 p.m. I have class at 6 a.m. in the morning, guys, right? How many of you are attending morning lectures? Tomorrow I am doing chemical bonding, right? Okay. Okay now? Chalo. Now let's see this. Amino acids you have. Now it contains amino acids. Amino acids have two things. One is NH2 group, other is COH group. So two things are there. One is NH2 group, right? Other is COH group. Both are there in the functional. Depending upon the relative position of amino acid, it is defined as alpha, beta, gamma. That means if you have, this is alpha amino acid because next to the carbon, that is COH, on the alpha position only you have NH2. That is why this is called as alpha amino acid, right? Okay, and you have alpha amino acid only. Let's say you have beta amino acid, then it will be COH, this is carbon, then here you will have NH2. So this is alpha, this is beta. Okay, they are both beta to each other. Let's say ma'am gamma, then you will have C, here you will have NH2. That is gamma, alpha, beta, gamma. Let's say you have delta, then it will be this gamma and this is delta, then you will have NH2. Okay, that is alpha, beta, gamma, delta, but we will talk about only alpha amino acids, that is this one, right? Let's understand, in aqueous solution the carboxyl group can lose. We are saying that in the aqueous solution what exactly happens, this is the acidic part. Acidic part wants to donate H positive, right? And basic part, because of its lone pair, it wants to accept H positive, right? So that's why what it will do, it will form a zwitterion where inter exchange of hydrogen will take place. That means here this H positive, it will lose and it will give to this base. And that is called as formation of zwitterion. This is an ion, but that is formed by the proton exchange between an acid and a base within the molecule itself, right? So a proton and amino acid can accept proton, giving rise to a dipolar ion, that is dipolar ion known as zwitterion. Overall this is neutral, but it has two polarities, one is positive, one is negative. Zwitterion amino acids show amphoteric behavior because of zwitterion, as they react both with acid and base. This part and this part, right? What they are going to behave, they are going to behave as amphoteric because they have acidic part as well, they have basic part as well. That's why they will behave as acid and base. Amino acids are crystalline solids, they are crystalline solids, right? These are water soluble and behave like salts rather than simple amines or carboxylic acid. So what they be, because of this zwitterion, they behave like salt rather than simple amines. NH2, they don't behave like simple NH2 amines or COH carboxylic acid. They behave like salt because of the inter-exchange of ions. They have the formation of zwitterion here. Right? Now, all alpha amino acids are optically active. Achha, tell me why all alpha amino acids are optically active? Because alpha means what? Alpha will always have this COOH, always NH2 on the same carbon, right? In this case, if you have one R group here and one H, tell me, is this chiral or not? Is this chiral or not? Tell me, bacha, tell me. Everybody, if you have R, this is C, this is H. This is alpha amino acid in general, right? This is chiral. This particular carbon has sp3 hybridization, right? It is having sp3 hybridization. It is having 4 different groups, so it is chiral. And whenever you have at least one chiral carbon, it is optically active. So all amino acids are optically active, but if R is equals to hydrogen, if this alkyl part is hydrogen only, then in that case it is not chiral. This carbon is not chiral. That is why this is optically inactive, and this is a question that they ask you. Optically inactive. So all alpha amino acids are optically active except for, because R can change and everywhere this will be optically active. There's only one condition where they are not optically active, that is when these two groups are same, and that is in case of glycine. That is in case of, this structure is of glycine. This they ask you, all amino acids are optically active except for glycine, right? Okay, right, everybody got it? Right, now let's talk about isoelectronic point. SAE students get scared of this, but actually this is also quite simple, right? So let's talk about what is this isoelectronic point. So guys, isoelectronic point is that point where, see, let's say you have connected anode and cathode here, right? This is anode, this is cathode, you have connected it. Now what will happen? You have a solution where you have the compound. So what will happen, because they have COO negative, they have NH3 positive. That is the reason what will happen. What we expect is that the negative ion should move, it exists negative and migrate towards anode. So now negative, see anode is positive, right? Cathode is negative. So all negative ion should migrate towards anode, positive ion should migrate towards cathode. That is an electrolysis that we have studied, right? है ना? Electrochemistry we have studied this now. So that is the thing. But now here the problem is, ma'am, there we have studied that okay, anode is positive, it will go, negative will go here, positive will go here. But the problem is it has both negative and positive because of the existence of Zwitter ion here. This amino acid is not moving only. So when it is not moving, the pH of that particular solution defines isoelectric point. So a pH at which amino acid shows no tendency, amino acid is not interested to migrate when it is placed in an electric field of anode and cathode, right? That is called as isoelectronic point. Okay, right everybody? Tell me. Right? Now let's talk about acidic solution. It exists as positive and migrates towards cathode. Now I'll tell about what is acidic solution. I'll just write here what is acidic solution and what is basic solution. Achha, see, in acidic solution what happens, in basic solution what happens. What was the compound? Let's talk about alpha amino acids. That was R, this is C, this is H, COO negative, and this is NH3 positive. You have acidic solution. Acidic solution will have H positive. So that means acidic solution, it will accept H positive here. So overall, isn't it positive? Can you see? Negative ion is neutralized by H positive. So overall, this is positive. Now in the acidic solution, it will move towards, because this is overall positive now. So it will move towards positive now. So it will move towards negative, that is cathode. So that is why it is moving towards cathode. Achha, if you see, this is R, this is C, this is H, this is COO negative, hai na? This is NH3 positive. You have basic solution. Base has which work? Base is like excited for which thing? Is like, I see proton, I am going to abstract the proton. So it sees this proton, it says like nitrogen, give me your proton, because what you have to do with this positive charge, give me your proton. It takes out the proton. Now overall this is a negative ion, that is why negative will move towards positive, that is anode. Okay, remember cathode is positive, cathode is negative, anode is positive. Okay, okay. Tell me. Is that clear? Is that clear? Now let's talk about for neutral amino acid, what happens, right? Neutral, wait a minute. Chalo, let's talk about this. This is some amino acid we are talking about in the neutral state. That means, Acha, can you tell me what is a neutral state? Neutral state does not define that it will be positive or negative. Neutral amino acids are when the number of acid and bases are same. So this is one acid and one base group. So it is neutral. Let's say here pKa value is, I'll just write here pKa value is X, Here pKa value is y, then you can say x plus y by 2 is the pH of isoelectric point, right? What about this one? This the values they will give you in the exam, right? So here what you will see, why it is acidic, because here number of acidic parts are more. So here what you will do, this is for, you will only consider acidic part. Let's say this pKa is x and this pKa is z, this pKa is y. Okay, so that will become x plus z by 2, right? Now what you have, you have 2 NH3. Now what you do, this is, let's say pKa is x, this pKa is y. Okay, just add pKa of 2 bases here. This pKa is z here. Okay, just add those pKas and of the basic part and you will get your answer. Okay, everybody, do let me know that is clear or not. Now this is a cramming part. This you can decide, right, whether you want to, like, whether you want to learn this or not. But I'll just mention some important that you must know. Okay, you must know about glycine. See, simple is that this R is differing, right? The R that I have written here, na, this R, H, NH3, this R is changing. So you can remember the value of R here in glycine. Alanine is also important. The lysine is also important. So all of them are important, right? Okay. So then these though must know, right? Then aspartic acid, all of them are important only, right? But still some of them are quite famous. Serine, cysteine, cysteine also, na, in our hair it is fine, we find it, this amino acid is there, right? Aspartic acid, glutamic acid also you must know, right? Then yes, so leucine, valine is also important, right? You will say, ma'am, why? Right? Arginine also you will see this. See, it's your choice if you want to do this or not, but at least know glycine, what is glycine and alanine. 5, 6, what I have mentioned, you can definitely know. Others you want to do or you don't want to do, that's your choice, right? So if you want to take risk, you can skip it. If you don't want to take risk, you can do it, right? Okay, but this methionine, cysteine, these though I don't think so they will ask you this, so you can skip this, right? Okay, these also you can skip. Histidine you can remember, right? Okay, so that is the thing, right, everybody? Yes. Huh. The difference is that total we have 20 amino acid. The difference is this. Their R group is different. But I would not, at this point, I would not advise you to remember all of them. Right? Right? I would not advise you to remember like all of them. Just remember some important that are repeated in your PYQs that I have mentioned. Right? Okay? Because learning all of them at this point is not possible, it's not practical. Even if you have a very good learning cramming skills, then you can do that, right? Okay, you choose this thing, right? Now let's talk about classifications of amino acids, right? So amino acids are classified as acidic, basic, neutral depending upon the number. So if carboxylic part is more, it is acidic. If amino part is more, that is basic. If both are equal, that is neutral amino acid, right? Two categories are where amino acids are divided. One is essential, other is non-essential, right? What is essential amino acid? Essential amino acid is which cannot be synthesized in our body, right? These things you have to provide to your body. Your body can't synthesize it themselves, right? That is why we have deficiency of all these things, right? Non-essential is those that can be synthesized by our body. So that is why they are not important to take it from outside, but essential is that our body cannot synthesize. You have to take it from your diet. Okay, basically amino acid is protein only, guys. Okay, amino acid, ma'am, how we eat amino acid, we I'm talking about protein, because protein is made up of amino acid, right? Just like glyco, you have monosaccharides from where carbohydrates are made, right? You have glucose unit, they connect together to form starch, cellulose, right? Similarly, in amino acids, they connect together to form proteins, right? And that we have protein. So protein, that's why it is so important, because some things our body cannot form by itself, right? So proteins are polymers of alpha amino acids. Alpha amino acids. Now remember this, you use alpha amino acids here, right? Only alpha amino acids I am talking about. That is the list that I have given you. That is of alpha amino acids. They're connected to each other by peptide bond or peptide. Just like you have glycosidic linkages, you have peptide bond, right? Let's talk about what is this peptide bond. You have this let's say here are, this is glycine, this is alanine, है ना? So now that is why it is called as glycine alanine glyalane, right? That's why it is called as this. Now guys, if you talk about this thing here, when you do the hydrolysis, H2 from here and oxygen from here, that is eliminated, or you can just simply say OH and H is eliminated. You will have CONH, C double bond O NH. Here Cu is left, here NH is left, and that is the thing which you will have, C double bond O NH, right? So what you exactly have, you have C double bond O. I'll just write it here, C double bond O OH. This is NH. So here what will happen? This thing will be eliminated, and you will have in the end, this thing will be eliminated, and in the end you have the formation of C double bond O. This is NH. Okay? That thing is there, C double bond O NH. That's why we have written it like that. Okay? So hydrolysis of peptide, when you give it water, it is going to give you back. Similarly, like hydrolysis of disaccharides were giving you back monosaccharides. No? Same thing here, right? Okay, that was glycosidic linkages. This is peptide linkages. Okay, understood? Tell me. Acha, based on hydrolysis, no, one more thing you must know. Let's say something is formed up of glyala, right? Some other protein also. Let's take, let's say glyala. Then you can see whatever CYS, cis you can take, val you can take. Okay, I'll take cis and val. Okay, ऐसे I am randomly arranging them. Okay, so you have, this is your amino acid chain. Okay, this is your amino acid chain. Now what you have, you do complete hydrolysis or partial. Let's say there is complete hydrolysis. This is partial hydrolysis. Okay? When you have complete hydrolysis, what will happen? All of them will be separated. This will be gly, this will be ala, this will be cis you will have here. All the amino acids you will have. But what if you have partial hydrolysis? Then what you will have? Gly ala, ala cis, then cis val. Okay? So that kind of, this thing is formed when you have partial hydrolysis. Okay, yes everybody, done. Yes beta, definitely. From this part, no, this part I told you, sometimes they ask you some new question as well, so that's why I told you this, right? Otherwise, if you ask me from these theory parts, they ask you the question from protein structure, primary, secondary structure, fibrous, globular. You should know the definitions here. Okay. So fibrous, now this is a very interesting part related to your body itself. If you talk about fibrous proteins, what are fibrous proteins? They are in your nails. Now tell me one thing, your nails and your hairs, they are water soluble or not? Tell me, is your nail, is your hair water soluble? You wash your hair, ma'am? Yes, ma'am, it is water soluble, ma'am. So much hair fall is there. It seems like my hair is water soluble, but that is hair fall, right? It's not like your hair are getting dissolved in water, right? There is a mixture that is formed. Huh? Homogeneous mixture, ma'am. No, nothing like that. Your nails are also not water soluble. Otherwise, you will never do any work with water. You'll be like, my hands, my nails will break, right? So that is insoluble in water. That is fibrous. So polypeptide chain run parallel and held together by hydrogen. Fiber like structure is formed. Wait a minute. First thing is, it is insoluble in water, like you have in your nails and your hairs, that you can remember as an example. Keratin is in your hair, right? So that's why keratin treatment, right? What is that keratin treatment? They give you artificial keratin, right, to smoothen your hair, right? Okay, to break these sulfide bond that is there. Okay, why my hair are like curly, right? Whenever someone has a lot of curly hair, they have a lot of sulfide bonds, right? Okay, I to love curly hairs. So polypeptide chains run parallel. In this case, exactly what happens in fibrous protein, the polypeptide chain means amino acids, they connect together, they form a chain. So what happens, polypeptide chain run parallel to each other, held together by hydrogen, and this is very important point, that how they are parallel, they are held together by hydrogen and sulfide bonds in the fibrous protein, right? Then fiber like structure is formed, that is, that structure is our hair, that structure is our nail, that is fibrous protein. Globular is chain of polypeptide coiled around to give a spherical shape, right? They coil around each other to give a spherical shape. That is why they are like a globe, a spherical shape. They are not parallel, they are like a globe, right? So that is why they are globular protein, right? They are soluble in water, like insulin that is soluble in water, right? Just know that which is soluble, which is insoluble. Now let's talk about the structure of protein. So you have four kind of structure of protein: primary, secondary, tertiary, and quaternary. Let's talk about that. Okay, four kind of proteins you have, right? Primary, secondary, tertiary. Let's talk about that. Firstly, what is primary? Primary is that, but it's like complexity is increasing. I'll tell you a simple way of understanding this. uh, let's say you're packing your bag. What you do, tell me, when you're packing your bag, the first stage is, like, I don't know if you are like really you're good in packing or you're not good in packing, but that's what I do. Like, when you, let's say you have your all the face wash and all these things, you put it in a some wash bag, right? That is the first thing. So first thing is, when you have those small things that you're putting, right? You have, let's say, your pants, you have your shirts. Okay, let's see how you put all the things in your cupboard. How you put it, it's not like you have your shoes and then you have your clothes and then you have in between you have your makeup thing, and in between you have your clips and all. This does not happen like that. Boys can't relate, I know, right? Boys are like, ma'am, everything is here and there only, what you're talking about, right? So see, in a systematic way, what you will do, firstly you will pack your shoes, you will pack your clothes, your shirts, you will pack your pants, right? You will pack everything, face wash, everything that is needed. So these are some primary sections that you are having, right? And here those first bonds, those first primary sections I'll talk about is amino acids. So smallest part of protein is amino acid. I'm connecting that. Okay, and you can also, I have one more theory of that. that I used to give to students, but some students can't relate to it. So I'll try giving you that theory as well. But let me give you this theory first. So now let's say you have all your pants, right? That is, all the pants are amino acids. You have connected them, you have packed them, right? Now you have one primary section, another primary section of shirt, another primary section of maybe your hair accessories and all whatsoever you want to have, your another section of shoes. Everything is systematic. That is all different primary sections that you have, where small amino acids are connected. So primary is the structure. Each polypeptide in the protein has amino acid linked with each of the specific sequence. This sequence of amino acid, that is said to be primary structure of the protein. So in primary structure, I only talk about each bag. I'm not talking about all the bags, I'm talking about each bag, right? In the secondary structure, what you have, right? Wait a minute, this is the naming of this, I'll talk about later, right? Firstly, let's talk about this. Then you have secondary. Two types of structure exist in secondary. Now, how you pack those primary structures together? Either you can pack them like this is your shoes, this is your clothes, this is your shirts, these are your pants, right? Like this. Or you can pack them like this is your shoes, these are your shirts, this is your pant, and these are your face wash and all things, right? So toiletry things, right? So now different arrangements are possible for you as well. Similarly, for here, different arrangements are possible of combining those different polypeptide chains together. So how we combine it? Either first is alpha helix. Alpha helix is like this. Alpha helix is like this. It's like a spiral. Okay, it's like a spiral. Let me see if I have any spiral over here, right? I don't think so I'll have it, but I can give it a try. Sometimes I have these things, right? Chalo, I don't have it. Okay, so it's like a spiral, it's like a spring you have. That is alpha helix. One, then two, then three, like this, right? Now if I talk about beta pleated, in this case it is like this, it is like this, like this. That is beta pleated. You go here, then it is connected like here. Okay, that is beta plated. Alpha helix is like this. Okay, so two types of structures can exist. First is alpha helix, second is beta. Secondary structure arises due to folding of backbone of polypeptide chain. How polypeptide chain is being folded here, right? Is the polypeptide chain folded like this, or it is folded like this? I also tell you simple snake theory. Snake theory, how to remember this? See, primary is snake has its own different parts, right? It's because these all look like a snake only, right? So how different parts of snake are connected to each other? That is polypeptide bond, each polypeptide bond. Now snake is like this or snake is like this. That is the secondary structure. How the snake is, what is the what is the structure of the snake? How you look at it? How it is bonded, right, within the polypeptide chain, right? And this folding is due to the backbone of polypeptide chain to the hydrogen bonds, right? Maybe this thing is happening because of the hydrogen bonds between them, right? Alpha helix is like right hand screw. H bond is between NH group of amino acids to this adjacent of helix. In the case of alpha helix, H bond is between NH of amino acid to CH of turn of to the CH of adjacent turn of helix. Like this is alpha helix, right? This is alpha helix. So in alpha helix, what you have, these two are connected like this. Beta pleated structure, peptide chains are stretched out to maximum extension and then joined by intramolecular hydrogen bonding. The structure is represented in the folds of Draffry. Okay, that I told you, that is the beta plated structure. ठीक है. Now if you see tertiary is how two secondary structures are connected. This is the thing that I told you when you are packing something. One pack is of your pants, one pack is of your shirts. How you connect those two different packs in your big suitcase, right? You have your big suitcase. How you connect them? Do you put it sideways? Do you put it up and down? Do you put it parallel to each other? Right? How you put all the different packages with each other, right? That is your uh, tertiary structure. What was the primary structure? The connection. How different pants you have pressed, and that you have, you know, different shirts you have pressed and you have ironed it, and after that you have, you know, put it in your uh, small bag, right? Small bag. Now in that small bag you have a section. This is pants, this is shirts, right? Now how this section looks like? Is this distorted like alpha helix, or is it like beta plated? That is how it looks like, right? That primary, when they're connected, how they look like. Tertiary is when you put different secondary structures of those bags together, how they will form, right? So it represents overall folding of polypeptide chains, further folding of secondary structure. So here this is having the snake. So if I talk about a snake, right? Snake, the connection of different parts of snake is first primary. How the snake is moving, is it moving like this, is it moving like this, that is secondary. Now you put the snake into some pipe, right? Into one pipe you put the snake, right? So this is that pipe where you're putting the snake. All different snakes you're putting in just one pipe, right? And that is your tertiary structure. It gives rise to two major molecular shapes, that is fibrous and globular. Fibrous is two pipes are parallel to each other. Globular is two pipes are connected in such a way that they form globe, like they form spherical shape. That is globular. Okay, this is, I'm talking about pipes, I'm not talking about the snake, right? It's just a way to remember, guys. Okay, there is no snake, no pipe here, and just a way to visualize things, right? So main forces which stabilize 2-degree 3-degree structures, let's talk about that. Proteins are hydrogen bonds, sulfide linkages, and van der Waal and electrostatic force of attraction, right? This I told you that how fibrous and globular protein are connected to each other because of hydrogen bond and because of disulfides, right? There are van der Waal interactions here as well. Now last is quaternary. Now just imagine there is one pipe, there is other pipe, there is third pipe. So many different tertiary structures are there. How these tertiary structures are connected to each other, further more complexity. So as you go beyond complexity, it's like have you seen that video where from the earth they have zoomed in? Firstly you will see atmosphere, then you will see building, then you will see someone's society, then you will see someone's home, then you will see someone's room. So you're zooming in, same thing, right? So as you go from quaternary to primary, you are just zooming it, that what is exactly there in this structure, right? So protein are comprised of two or more polypeptide chains referred to as subunits. Spatial arrangement of these subunits with respect to each other is known as a quaternary structure, right? Okay, tell me everybody, is that clear? Is that clear? Any problem here? Tell me. Any problem here, guys? Any problem here? So this is what you have. This is this circles are the amino acids. They are connected. That is primary. How alpha helix or beta plated? Alpha helix is like this. If you see, it is going and it is surrounding, it is moving like this, then it is going, it is moving like this. It may look, ma'am, this is also like this, ma'am, this is also like this, but in reality it is alpha helix is this and beta plated is this. Beta plated is this, like a wave. Okay, that is beta plated. Acha, after this, then what you have, you put them in a pipe. Okay, how they are connected, alpha helix to alpha helix units, how they are connected to each other, that is tertiary. Further, you have this and same kind of other tertiary structure that is connected to each other, that is quaternary. Okay, right everybody, tell me everyone. So naming of polypeptides is, naming starts with N-terminal residue and suffix "ene" of amino acids and replaced by "ile" for all except amino acids of carbon terminal residue. As a naming is not important for you, right? You can see starts from N-terminal residue, right? And suffix "ene. It ends with "ene" here, right? And rest of them have "ile", "ile", "ile" here, right? Naming you can skip, right? You can skip the naming, right? Okay. Acha, now denaturation of protein, that is quite important for you. Let's talk about that. Native proteins, if you talk about protein found in biological system with a unique 3D structure and biological activity is called as native protein, that is found in a biological system. When a native form of protein is subjected to physical change in temperature or chemical change, that is change in pH, hydrogen bonds are disturbed, because we see there are so many bonds, disulfide bonds, hydrogen bonds, van der Waals forces are there which are connecting these amino acids so that protein can exist, right? Due to this unfolding of proteins or uncoiling of helix structure. Now helix structure is what? That is a that is helix structure, and proteins loses its biological activity, the activity that is it is doing in our body. This is called as denaturation of protein. So what exactly happens when you increase the temperature, when you change the temperature, or you do some chemical change here, what happens? Its structure changes. Alpha helix, beta pleated structure, they are uncoiled, their bonds will break, and hence that is denaturation of protein. During denaturation, 2 degree 3 degree structures are destroyed, but this is very important, primary structure remains intact. This is what they ask: during denaturation, which structure will remain intact as it is? Right everyone, do let me know in the chat box, right? Okay. Acha, after this we are only left with DNA, RNA, है ना? Yes, then we'll start with uh, nucleic acid. We are left with only that part. After that we will start with the qualitative quantitative analysis, right everybody? Do let me know. Clear? Done? Let's see. Now it's already 9:05. So now I'll give you a good amount of break. Tell me how, because I also need to do dinner. It will take me 11, 12 p.m. to complete that. I don't think so 11. I think if I come by 9:30, then it will go around 11:30. Okay? Yes. Huh, because primary structure na, they are not formed from hydrogen bonds. Primary structure have a solid bond. If you see, primary structure was proper bond, है ना? Primary structure was C double bond O NH. This is a proper covalent bond that is existing in primary structure. In secondary, it is how it is getting connected to alpha helix and beta pleated because of hydrogen bonds. So hydrogen bonds will break. That is why that structure will break. Okay, chalo. Now that's it, guys. Now I'll see you all at 9:30 p.m. This is the break time, and after that we'll do DNA, RNA. This is a very interesting part. Break time, right? Till 9:30. Till 9:30 p.m. Have your dinner. Have your dinner, please. After that, don't tell me, ma'am, I need dinner break. Right now, only have your dinner. Right? Okay, chalo. Now I'll see you all after the break. Hi students, so I am back in the class. Everybody do let me know if I am clearly visible and audible to all of you or not. Yes. Yes students, do let me know. Let's complete biomolecules, and after that let's start with qualitative quantitative analysis. Right everybody? Let's see. Right, so if you talk about nucleic acids, then nucleotides join with nucleic acids are nucleotides join with each other through 3,5 phosphate linkage to give polynucleotides, which further are nucleic acids. So I'll just tell you here. Basically nucleic acid are of two types, that is RNA and DNA. Right, RNA is ribose, it has ribose sugar, and DNA is 2-deoxyribose sugar. Right, so basically what is ribose and deoxyribose? Firstly you have to understand that. Right, this is the ribose sugar that you have. Right, this is ribose sugar, just like fructose you have ribose sugar. But in case of deoxyribose, on the second position, this OH is replaced by H. So here you have on the second position two hydrogens. Here you have one hydrogen and one OH. Right? That is the difference. This is this is ribose and deoxyribose. Now, if you see what exactly happens, three things. It is nucleotides are made up of three things in detail. That is sugar, that can be ribose or deoxyribose. If it is ribose, it is forming RNA. If it is deoxyribose, it is forming DNA. Then second part is phosphoric acid group. Third part is nitrogen bases. Right. So first part we have seen that there is sugar, that can be ribose or deoxyribose. Right. Now the question based on that is sugar moiety in DNA and RNA molecules respectively are what? So J 2022 question, that is, if you see deoxyribose is in the D2-deoxyribose is there in DNA, and in RNA you have beta D ribose. So answer will be B is the correct answer. That was quite a simple question. Okay, right? Okay, yes. Now if you see this here, I'll just make this thing here. Now, oh my god, oh my god, oh my god. Wait a minute. By mistake, I did it. Wait a minute. Huh. Then if you talk about, there are two things. One is nucleotide, other is nucleoside. Nucleotide has all the three parts. It has base, it has sugar, it has phosphate. Right? But nucleoside does not have the phosphate group. Okay. Now, if you talk about in nucleotide or nucleoside, right, sugar can be ribose or deoxyribose, right? But ma'am, how this is connected to base and phosphate group? I'm so sorry. So if you see, sugar may be ribose or it may be deoxyribose, but how base will be connected on the first position and the phosphate group will be connected on the fifth carbon. That's how to this sugar phosphate group and base is connected, right? Phosphate group can be phosphoric acid, phosphomonoester, phosphodiester, phosphotriester. Simple thing is, guys, phosphoric acid, you know, H3PO3, H3PO4, that is your phosphoric acid. Replace 1 with R, replace 2 with R, replace 3 with R. Right? This is monoester, diester, triester. So anything can be there. This phosphate group can be anything. Understood now what we have? Thing is, nucleic acid are made up of, they can be two types of nucleic acid. One can be nucleotide, other can be nucleoside. Nucleotide has all the three things. Nucleoside Sideline, which you sideline? You sideline phosphate group here. Phosphate group is not considered in nucleoside. Okay. Now, another classification is it can be DNA, it can be RNA. DNA and RNA will have different sugars. DNA will have deoxyribose, RNA will have ribose. Now, phosphate group, the first part was sugar, other part was phosphate. Phosphate group was these many. Third part is base. What are the different types of base that you can have? Right, so let's talk about nitrogen bases that are there in nucleic acid. In nucleic acid, first thing is derivative of purine can be there, derivative of pyridine can be there, or then there can be usually heterocyclic simple nucleic bases. So you don't have to remember the structures and all, right? But still I have given you all the structures here. But remember, there are 5 types of nitrogen bases, and this is a very important part. First is adenine, guanine, cytosine, thymine, and uracil. Now, what question they ask you? Always remember, this is one DNA, this is other DNA line here. Where you have sugar here, you have phosphate group, you have nitrogen base. Sugar, phosphate, nitrogen. Sugar, phosphate, nitrogen. Sugar, phosphate, nitrogen. So nitrogen bases that you have here and here, they are connected. They are forming hydrogen bonds with each other. And that's how in DNA you have double structures. Double means double helix. How 2 helix structures are connected. They are connected by the hydrogen bonds between the nitrogen bases. Guys, just give me a second. Something is irritating in my throat. Louis, listen. 2-3 days I have been looking at your chats. Listen one thing. If you're genuinely in class 8th or 9th and you are learning here, that's good. But understand, other students here have their exam in 30 days, right? So kindly don't disturb anyone, because you will be also there at some point, right? They have a lot of pressure. Don't distract them, right? Okay. Now, if you see, hydrogen bonds are formed between G and C, and 3 hydrogen bonds are formed between G and C. Between adenine and thymine, it is formed 2 bonds. Between adenine and uracil, it is formed 2 bonds. Okay? Right, everybody? Understood? So these are the hydrogen bonds in which they are existing. Which one of the following is correct structure of cytosine? Yes, they have asked you the structure of cytosine. Then so you will have to do this. You can't ignore this structure. So cytosine structure, you can see that is the structure of cytosine. You have to do this. JEE 2021, they have asked you this question over there. So answer is going to be D is the correct answer for cytosine. Right? Now, remember that when we talk about DNA and RNA, different pairs exist here. In case of DNA, you have thymine. In case of RNA, you have uracil. Others are same, right? In case of DNA, you have thymine. Here, what you will have? You will have G and C, hydrogen bonds between them. And here you will have A and T, 2 hydrogen bonds between them. Here you will have G and C, 3 hydrogen bonds, and T and, A and U, A and U, 2 hydrogen bonds between them. This is what you will have. Tell me, guys, if that is T and U, A and U. Okay, so in DNA you have thymine. In RNA you have uracil. Okay, what is the difference in DNA RNA? DNA has ribose, DNA has deoxyribose, and RNA has ribose. DNA has thymine and RNA has uracil. That is the difference. Other things are same, right? Okay, tell me if that is clear, right? Okay, everybody, now let's see the structure of DNA. James Watt and Crick gave a double. Now, why this is a double helix structure? Double helix means this is one helix, this is other helix, they are connected to each other. How they are connected to each other? Because of the hydrogen bonds existing between the nitrogen bases. Two nucleic, I'll just show you the structure firstly. If you see the structure, this is the sugar. Okay, can you see this is sugar? This is phosphate group. Can you see everyone? This is the sugar. In DNA, like you have deoxyribose sugar. This SS is sugar. Okay. Then this circle is phosphate group that you have. Okay. And they are connected by the nitrogen bases: adenine, cytosine, thymine, guanine. Now, if you can see, three bonds, 1, 2, 3. 1, 2, 3. 3 are existing between G and C. Between A and T, only 2 are existing. Between G and C, again, it doesn't matter G is here or there. If G and C, they have hydrogen bond, it will be 3. Between A and T, it is 2. Can you see this over here? Right? So this bond is very important, that how many bonds they have. Right? Okay? Now see this thing here. Two nucleic, now you'll be able to understand the theory part here. Two nucleic acid chains, two chains are there, are wound about each other, held together by hydrogen bonds. Hydrogen bonds is between pairs. Two strands are complementary to each other because the hydrogen bonds are formed between specific pairs. And what are these specific pairs? Adenine form hydrogen bond with thymine. Cytosine form hydrogen bond with guanine. Okay? How many bonds? 2 bonds here and 3 bonds here. Okay, everybody, tell me. DNA is known this, they too list by hydrogen bond. Sugar phosphate appears from rails and the bases appears from rungs. So what exactly they want to say? Sugar and phosphate appears to form rails and the bases appears to form the rungs. So this is whenever you are going in the stairs, right? These are the rails that you are holding. So this is forming the rails and these are forming the stairs. One step, second step, third step, these are forming the rungs. Okay, just an example. Okay. Now let's see the structure of RNA. RNA has deoxyribose, it has uracil. In secondary structure, single stranded helix is there, is present, in which sometimes folds back to itself because of the hydrogen bonding. It folds back to itself, right? It has single this with the hydrogen bonds with each other because of the nitrogen bases. So there can be three type of RNA: primary, secondary is primary is primary is the sugar molecules connected to each other, that is primary. Then how they are connected, like are they connected in alpha helix or they are connected in beta pleated, that is the second thing. That means how these nucleic chains are rolled, right? Tertiary is single strand may rewind over itself. So what will happen? You will have this helix and it is rewinding over itself only. This is the tertiary structure. Can you see? This is the tertiary structure. Primary is what is happening here. This is sugar connected to each other, nitrogen, that is primary. Secondary is whether it is this or it is this. Tertiary is whether it is rolled it to by itself like this or like this. Okay, this is tertiary. Right, everybody? Tell me. The homogeneous chain that you have, na, like in DNA, this chain that you are forming, this particular chain that you have here, this chain. Okay, because in In case of RNA, instead of T, you just have U here, and sugar is different. Everything else is same, right? But that is also single stranded. This is double stranded, right? Okay, tell me. Okay, everybody. Then you have, I'll just show you the structure of DNA, RNA here, right, to have more accuracy. If you see structure of DNA, RNA, DNA is double helix. So you have 1, 2, 3. This is second. Okay. 2 helix are connected to each other. In this case, you have only 1 helix. That is RNA, right? Okay. This is what I want to tell you. The difference is here you have uracil and here you have thymine. Here you have deoxyribose, here you have ribose sugar. Understood now? What is yes? RNA is single stranded. As you can see, DNA is double stranded. Okay. Tell me any problem here. Now, let's see the types of RNA that you have. RNAs, molecules are of 3 types and they form different functions, perform different functions. One is messenger, other is ribosomal, and third is transfer. Just remember there are 3 types of RNA. Messenger one is mRNA, ribosomal is rRNA, transfer is tRNA. That's it. That's it. More detail you don't have to go, right? Now complementary bases, as I told you, adenine and thymine are complementary with double bond, and guanine and cytosine are complementary with triple bond, right? Randomly they don't appear, they have a fixed pair, right? Okay. And also remember, like adenine and thymine, adenine and uracil is also a complementary one, that is with 2 bonds. This is in case of DNA. Again, I am doing the same thing. This is in case of RNA. Okay? Acha. Now let's see. Thymine always pair up with adenine. Cytosine always pair up with guanine. As you can see, it forms 2 bonds and this forms 3 bonds. Always 2 bonds, always 3 bonds. Right, everyone? Let's see some important questions here. This question is, they are saying the compound A is complementary base of which one? Compound A is a complementary base of which one? Anyone in the chat box? Compound A is a complementary base of which one? First, you need to understand what is this compound A, right? If you see this here, this compound A, wait a minute, let me just show you that. This compound A is nothing but that is CH3, C double bond O, NH, NH, that is thymine, right? And complementary to thymine, what you have? You have adenine. So complementary base is going to be adenine here, right? Okay. Which of the following statements not correct about RNA? It always double-stranded alpha helix, usually does not replicate. It is present in nucleus of the cell. Acha. Not true. It is always double stranded. First is only not true. Okay? It does not replicate. DNA replicates. It is present in nucleus of the cell. It controls synthesis of the protein. Right? That is all true. First is not true. It is not always in double stranded. It is single stranded. Okay? So first is not true. Other things are yes. DNA will replicate, RNA will not replicate. Because of DNA replication only, we are existing. It is present in nucleus of the cell, that is true. It controls the synthesis of the protein, that is true. That is the work of RNA, right? Okay? Understood? Chalo. Now let's talk about vitamins. Acha, this is all, you must know the, like, which vitamins what. I'll just tell you that. Some organic compounds are required in small amounts in our diet, but their deficiency cause specific diseases. Now, now, if you have gone through any vitamin deficiency test, right? Vitamin D, vitamin B12, that is usually in deficiency. Because I'll tell you why. If you see this here, We need vitamin A, vitamin B, vitamin C, vitamin D. We need all of these things. Vitamin C is ascorbic acid, we need that, right? So some of the further named subgroups are like B is divided into B1, B2, B6, B12, right? In my life, B12 is very important because I always have deficiency of B12. And I always, I think most of the Indians, they have a deficiency of vitamin D also, because we don't sit in sunlight and absorb the sunlight as such. So we have that deficiency. So first is fat soluble vitamins, and you can remember this by Kida. Vitamin K, vitamin E, vitamin D, vitamin A, they are fat soluble. And what are water soluble? Vitamin B and vitamin C is water soluble, but vitamin B12 is not water soluble. Okay, vitamin which are soluble in fats and oil but insoluble in water, they are stored in liver and adipose tissues. So vitamin A, vitamin D, vitamin E, vitamin K, they are stored in our body, right? And still we have deficiency of vitamin D. That is, oof, still we have deficiency of that. Now vitamins which are soluble in water but are insoluble in fat. Water, they are soluble because they are soluble in water, that's why they are excreted out by urine. Okay, so they are readily excreted in urine and cannot be stored in our body. But vitamin B12 lies here. Vitamin B12 can be stored. That is why when you I had vitamin B12 should be around 400 something, 500. I had vitamin B12 80. 1.5 years back, I think 2 years back itself, I have like 80 was literally my count of vitamin B12. And I was like, it's so much deficiency that I need to take tablets. Vitamin B12, that is your this is your I'll tell you, I just forgot the name only. Kya tha? That was the name of the tablet. That is methyl corbyl something. I forgot the name itself. Right. So it is soluble. B12, vitamin D, vitamin E, vitamin E, vitamin K, that we usually talk about, right? That we usually see on our test when we check our vitals. They are fat soluble. That's how we can check. These vitamin C and other vitamins, we have to take it on daily basis. Like vitamin C is in lemon, orange, we have to take it on daily basis, right? Others also we need to take it on daily basis itself. Now, ma'am, why they are so important? Now, these are the sources and their deficiencies. You can see the chart yourself. There's nothing to explain here, right? It is just a chart. You need to see this. Like vitamin, this is important for you as well. In general life also, this you must know. Like vitamin 6 is in milk, egg yolk, cereals, grams. B2 is in egg white, liver, kidney, milk. Milk has everything if it is pure. Yeast, green vegetables. Vitamin A is in carrots, butter, milk. Vitamin B12, that's the reason vitamin B12 deficiency is there. I'm a vegetarian, right? That's why now I'm eating egg daily basis. Like vitamin B12, I need you, right? So fish, meat, egg, curd, it has vitamin B12. Then vitamin C, ascorbic acid, that is I told you, amla, citrus fruits, green leafy vegetables. Vitamin D is exposure to sunlight, egg yolk, and fish. Vitamin E is vitamin vegetable oils like wheat germ oil, then sunflower oil, all these vegetable oil. Vitamin K, green leafy vegetables, spinach and all, broccoli, it has vitamin K. है ना? This so you must know, right? Generally in life you should know, right? But vitamin has very less probability. You don't. I would have been at your situation. I would have, taken risk and not learn this, right? So I would not that much advise you, but still, who don't want to take risk, they can do this, right? But little bit knowledge you should have about this. Hormones are molecules that act as intercellular messengers, right? In our body you have so many hormones, right? Our bodies, all the emotions that we are feeling, the anxiety, depression, happiness, whatever it is, Thank you, Arham. Thank you, Arham Saeed. Thank you. Chalo. Now, all is regulated by hormones in our body, right? These are produced by endocrine glands in our body and are poured directly in the bloodstream, which transports them to the site of action. This helps to maintain the balance of biological activities in the body, right? So all these hormones you have, first thing is hormones is insulin. Insulin helps in keeping the blood sugar level within the narrow limit. That's why whenever we say someone has diabetes, actually they have fluctuation in the insulin. That's why they inject insulin in their body, right? It's not though we should not eat sugar that much. We have studied carbohydrates. Sugar is good when you eat it in the form of fructose along with fiber like fruits, right? But otherwise I hardly eat sugar. I don't remember. I like I have from the past 3 4 years I am not eating sugar only. It's not like, yes, definitely when I have to eat something really tasty that is made up of sugar, then I eat it, but not that much, right? So insulin level is not because someone is eating more sugar, right? It is basically because of the hormones fluctuation that is there, right? It is usually genetically transferred, diabetes and all. So glucagon, it tends to increase the glucose level in the blood, right? That is glucagon. uh, then epinephrine and neophrinephrine, this all you don't have to remember. They mediate responses to external stimuli, like you have to have touched some cold surface or hot surface, right? Then growth hormones, sex hormones, that this is for the reproductive parts. Then you have thyroxine, it is produced in thyroid gland. Now this also you must have seen so many people, they have this problem of thyroid, right? It is iodinated derivative of amino acid tyrosine. Abnormally low level of thyroxine leads to hypothyroidism, which is characterized by letharginess and obesity. Increased level of thyroxine causes hyperthyroidism. So basically, if you know this thing, it's a very famous now in our salt that we have in India that has iodine in it, right? Why? Because India once was deficient of iodine, right? So this problem was there, right? Okay. So that's why now in our salt, we usually say that we should have sendha namak, but you should have a simple salt. Sendha namak you can use a little bit, but normal salt you should use, which is iodine, because now we are free from that thing, because in our salt we have iodine. We need it, right? So then guys, this is steroid hormones produced in endocrine. This you can see yourself, and these are all the examples and all, right? Da, 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 da. Okay, this you can see yourself as well. There's nothing to teach as such. I would say you can, ignore this as well, right? Then these are all the hormones: progesterone, estradiol, testosterone, right? These are all the hormones, which you can, I mean, I don't think so they will ask you in JE. In NEET, so students already know themselves. But in JE, is very rare chance. I think DNA, RNA, then protein structures, amino acids, or most important is carbohydrates and DNA, RNA. That is most important. That you should not skip. Carbohydrates and DNA, RNA. In my opinion, they ask you questions from DNA, RNA, and carbohydrates. That's all we have done. Hormones, vitamins, still you can like skip, right? Okay. Bitter that much, so I don't know, Rasik, but yes, definitely it is associated with insulin levels, right? It is associated with that. Yes, because I have seen people who eat a lot of sugar and still they don't have diabetes. I have seen people when they were born itself they had diabetes because of genetics, right? Some people develop diabetes, right? So it has a lot of things, not only sugar, right? It is diabetes is not caused because of sugar, right? But yes, once you have diabetes and after that you can't eat sugar because it your insulin is not able to maintain the glucose level, right? Practical organic. See, practical organic chemistry has salt analysis and other things as well. Right here, we'll be talking about not practical with qualitative quantitative analysis. We'll be talking about methods. We'll be talking more about percentage calculation of different things. So it is more of numerical that they have asked you. Okay, this is not to be skipped. This is very important. Okay. Yes, vitamin B12 is the exception. You are right. Acha, tell me, shall I start with this? Now you will find it quite easy because the way I have made it now, you will be like, ma'am, you have made it super easy for us. These are really amazing notes, right? So you will not find it difficult. I'll give you only one formula to remember. That's it, right? Trust me, you will find it easy to do questions, and this is a very probable topic, right? It is not connected to anything else in your chemistry. So if you say, ma'am, I am not good in organic chemistry, it is an individual chapter itself. Biomolecule was also individual chapter. Even topics are individual. Carbohydrate is not related to amino. So you can do selective topics here. You skip everything, ma'am, I want to do only carbohydrates and DNA, RNA, do that because that has high probability instead of skipping the full chapter, right? Even in qualitative, quantitative, I would say purification I did. There also, see, questions are asked from purification also. But here, more chances are there, right? Okay, let's do. Let's start. Cobalt. Cobalt. B12 have, I don't remember, some cobalt tablet, hai na, that was there. Yes, you are right. So let's talk about firstly Liebig's method. First thing is organic compound, we need to understand whether it has carbon or hydrogen. For carbon, whenever an organic compound it has carbon, it will always give you carbon dioxide. And now I am writing one thing everywhere, that is detection compound. Now I'll tell you one thing, detection compound is not a bookish language. It is not written it in any book. What is detection? It is not an official thing. Okay? When I write the formulas so that you can use that formula, I'll give you one detection compound everywhere in all the processes. So detection compound, don't say, ma'am, it is not written in my book. It is not official thing, right? So it is just to make you learn, I'm writing those detection compound, right? Okay? It was not given by someone. So this is detection compound. That is going to tell you that carbon was formed. This is the detection compound in carbon. So what you do when you react carbon with oxygen, it gives you carbon dioxide. How you tell that carbon dioxide is there? Carbon dioxide turns lime water, that is COH twice, milky, that is CaCO3. So it turns lime water milky, right? That is first thing. Second is, if you have now this all is happening with CO when it is reacted with copper oxide, right? So with if that organic compound has hydrogen, it is going to give you water. And how do you, this water will tell you that you have hydrogen present here. This is the detection compound. So whenever they ask you percentage of carbon, CO2, remember that is the detection compound, DC. Okay, DC is CO2. In this case, DC is water. How you understand water is formed? If it turns anhydrous copper sulfate to blue color, crystalline form of with water of crystallization copper sulfate, then it is definitely water, right? Okay, tell me. Tell me. Understood? You have carbon, which is purification method. Beta purification, either chromatography or they will ask you from distillation. Most important is chromatography, right? Acha, tell me. Carbon, CO2, hydrogen, H2O. Now see this. Then there is Lissagany's test. This is all qualitative analysis. We are not doing the formulas now. I am just telling you which compound is formed where. Lissaginase test, what exactly happens in Lissaginase test? Let's see. So what you have a very small tube where you have sodium, right? You put organic compound in that small tube, means it will be this much small. It will be like this kind of tube will be there. So you put sodium, you put organic compound, you start heating it, then you fuse that organic compound in the tube, in the water, and it will burst out, and it will give you a solution. After that you filtrate it, and the filtrate that you will get is actually lissaginase extract. Okay, so that is important. This is how you make it. Take a small piece of dry sodium in the fusion tube. That small tube is fusion tube. Heat the tube slightly on the Bunsen burner. Heat it. Add a pinch of organic compound into it. Then heat it slowly to start so that the compound reacts with sodium metal and tube becomes red hot. Right? It is almost on the verge of breaking, and then you put it in the water. Red hot fusion and then plunked into distilled water, then cooled and filtered. Now you cool the solution, you filtrate. It was one of my favorite things to do in the lab, right? The filtrate is called sodium fusion extract or lissaginase solution, right? That is called as sodium fusion extract. Okay, sodium fusion extract or lissaginase solution. So based on this also they ask you what is lissaginase solution. Now the next question that they can ask you is why this is formed, why you make lissaginase solution, why don't you directly react the organic compound with something else, why don't you do that? It is because we want basically what happens here in this case, you have ionic bonds. Organic compound will have covalent bonds. So we want to convert covalent bonds to ionic bonds so that this detection becomes easier. Understood? If they ask you why you need to prepare fusion, because this is your PYQ what I am discussing. I am discussing your PYQ, right? So why lissaginase test is important? Why fusion tube? Why you are doing this? Because we want to convert covalent to ionic bonds, right? We want to convert covalent bond to ionic bonds. That is why we are doing this, right? If in the solution you have carbon and nitrogen, it will form NaCN. If you have sulfur, it will form Na2S. If you have halogen, it will form NaX. Now we will see how these three things are, how we'll do the reaction of these three things. So first is test for nitrogen, right? That is in case of nitrogen. When you talk about nitrogen, you have NaCN. These reactions are very important. This has been asked in your PYQs. Okay. So test of nitrogen, just remember this reaction that NaCN, that is the fusion extract. This sodium has reacted with the organic compound and made this particular compound, ionic compound that easily can react here. So NaCN can react with FeSO4. It gives you Na4FeCN6, which on further reaction with Fe3 positive converts this into Fe4FeCN6, which is Prussian blue. That is very, very important. This full reaction is very important. But if you guys are thinking of skipping practical chemistry, now do that. I'm not saying don't do that. Okay? Because practical chemistry is also not a priority thing. But this thing is also there in practical chemistry. Right? So that's why this becomes, and chances are if they ask you, they will ask you something like this. Right? Very high chances it has. Right? Okay? Right? Yes. Now let's talk about the next thing, that is test of sulfur. In sulfur, see what you have. You have Na2S. Now we will see the reaction of Na2S. When you react this with acetate, lead acetate, it had PBS, and that is having a black precipitate of lead sulfide. So what you have black precipitates of red sulfide. This is having black precipitate, black. Prussian blue is of blue color. So whenever you're detecting something, you want to see it or you want to smell it. Okay, in CO2 we saw white precipitate of CaCO2. In hydrogen we saw copper sulfate to hydrous copper sulfate, white to blue color. In this nitrogen you saw Prussian blue color. Here you saw black precipitates. And when this also is a very famous reaction, this is Na2S reacted with what? This is called as sodium nitroprusside, right? On treatment with sodium fusion extract with sodium nitroprusside. This is sodium nitroprusside. What will happen? Na2FeCN5NO you have. Here when you react this, instead of Na2 you will have Na4. Instead of NO you will have NOS. Okay? Understood? Right? Tell me. Tell me in the chat box. Right? Okay? Now, this is actually of violet color. So I'll just write here. This is violet color. Okay, here violet color is formed. Then in case of when you have nitrogen and sulfur both, then the fusion extract that you will have is NaSCN. Instead of NaCN or Na2S, you will have NaSCN if nitrogen and sulfur both are present. Then it is going to give you this particular reaction where Fe3 positive reacts with SCN, like means NaSCN, to give FeCN. It can also be written as FeCN thrice, or it can also be written as FeCN2 positive. That is having blood red color, and that is also very important. See, this reaction is very important. This, as it is, they ask you. This is also very important. This is also, you can say, important. Where more stars, that means that is more important. Okay? Understood? Then test of halogens you have. In case of halogens, guys, what we do? In case of halogens, you have NaX. We reacted with AgNO3, it forms AgX. Now, AgX can be of different things. There can be AgCl, there can be AgBr, there can be Ag. This is AgCl, AgBr, AgI. Okay, these three things can be there. So AgCl is of white color, AgBr is pale yellow, AgI is yellow color. It is soluble, it is compound silver that we have written. It is soluble in ammonium hydroxide. It is sparingly soluble. This is insoluble, right? Okay, this is what you should remember. How you see and you see, okay, this is a yellow color, bright yellow color. That means iodine is present. This is white. That means chlorine is present. This is pale yellowish, right? That means this is bromine is present. Okay, that's how you will see these things. Then next, say you have test of phosphorus. Now that's a different test. In case of phosphorus, we are not using any Lissagany's test, nothing. What we are doing here, the organic compound is heated with sodium peroxide, that is Na2O2. We are not using any sodium fusion here. This is not happening here, right? Na2O2, the phosphorus present in the compound is oxidized to phosphate. So if you have the phosphorus present here is oxidized to phosphate. Now further reaction will do. The solution is boiled with nitric acid, then treated with ammonium molybdenum. So this particular thing is important. If you don't want to remember the full reaction, don't do that. Just remember one thing, that what you have phosphorus that reacts with ammonium molybdenate. Molybdate. Molybdenate, what I'm saying. This is MoO4. Okay? This compound you must know, that is your detection compound. This compound is your detection compound. That is NH4, it is positive. PO4, it is 3 negative. When they are connected, this becomes 3, this becomes 1. Okay, this is formed. Along with this, MoO3, you write MO, replace one oxygen here, this is O3, replace one oxygen with 12 here, this is 12 MoO3. This compound you must know that is yellow color, molybdate. Molybdate. Done everybody? Okay? No. We want to have this 3 positive as such. Right? So this is x minus 1 is equals to plus 2. Then only x will have plus 3. Okay? So it is ferric here. Right? So it will be plus 2 only there. Right? Or you can also say it can also be written as, because if I see this is actually plus 3 oxidation state. So here that's why it can also be written as this is plus 3, this is SCN negative. So this can also be written as FeSCN thrice. That is also the same thing. Okay, so don't get confused. These are not different. These are same only. Right? Okay. Understood? So in this case, all you have to remember is that this thing, right? Just remember this compound that is having yellow color. Just remember this compound. Okay, guys. Now I'll just mark all the detection compounds here. I'll just write it over here. This is the full-fledged chart that you need to remember. Carbon detection compound is, I'll just write the detection compounds here, which you will use further, right? This is CO2, H2O. Here, you will have this, so you will not use only nitrogen. I'm talking about now we are moving towards quantitative analysis. We need to find the quantity. So that's why I'm marking the red portion, that is about the quantity. You will use this thing there, you will use this thing. Halogen you will form there. Chalo, rest of the things I'll tell you there. Right? Now just remember one thing. That in case of carbon, CO2 is formed, we detected by CaCO3. This is formed, we detected by this copper, hydrous copper. This is of blue color. And here if you see NaCN, we have Prussian blue, this compound is there. We have PBS, black PPT, we have this violet color, we have this blood red color, we have this white color, this is pale yellow, this is dark yellow color, and this is yellow color. These are the color, these are the compounds that you must remember. Tell me. Okay? Okay? Understood? AgBr, AgCl we will use there. Okay? That we will use. Acha, now see, very simple questions are asked to you. This is your JEE 2025 question, that is, in Lissagne's test, the covalent organic molecules are transformed into ionic compound. Why? This I told you, na? Why? This is true. Sodium fusion extract of organic compound have NNS, gives Prussian blue color with FeSO4 and this. Having nitrogen and sulfur. With nitrogen and sulfur, what it was giving you, if you see this. With nitrogen and sulfur, it was SCN. It was giving you blood red color here. Right? So the answer here will be statement 1 is true, but statement 2 is false. Because this is true that covalent is getting converted to ionic. But with this reaction, if you have nitrogen and sulfur both, it will give you NaSCN. And that gives you FeSCN thrice, and that is of blood red color. Okay, no Prussian blue is formed here. So that is false. Understood everybody? That is your JEE 2025 question, right? Acha, let's see next one, this one. That is nitrogen detection in an organic compound is carried out by Lissagne's test. Blue color formed corresponds to which of the following formula, right? And Louis, you are asking me so many questions. Actually, it's not one experiment. You have tons of experiment. Go and see that is in your practical chemistry, right? And in practical chemistry, in theory part, you have less. There are so many reactions that you have, right? This is one of the methods that we use. Okay, that is in your syllabus that I'm doing, right? So nitrogen detection, this Prussian blue is formed in this case, right? What is Prussian blue? FeCN6, right? And that is twice, so answer will be B is the correct answer. Fe4 FeCN6 twice, that is, this one is the correct answer here, right? Okay, just remember these. I told you the formulas and the colors you need to remember. Based on that, directly the questions will be asked. Acha, now let's see how to calculate percentages, right? Let's see that. Advert, we are now going to talk about quantity only. So we'll talk about molecular weights and all. Right? Okay, everybody? Acha. Now let me just see. Yes, I'll give you the formula here. Let's not talk about all these things, right? Let's get this straight. A known mass of organic compound, here we write this. This is all that you have read in qualitative analysis. What you have to remember, mass of the organic compound I'll always take as W. This is the general formula that I was talking about. I'll always take this as W. Detection compound, I'll take it as M. So how do you write it? You write percentage of that element. Percentage of element is equals to, this is molar mass of element in detection compound. I'll tell you how to apply this formula. In the starting, you might find this formula difficult. Trust me, till the end, when you see from this one formula, you can answer multiple formulas, you will find it easy. Right? This is first thing. It is multiplied by M, that is mass of detection compound. Because it's percentage, it is multiplied by 100. It is divided by W, that is mass of organic compound. And here you have, this will be given in the question, this will be given in the question. Mass of detection compound, mass of organic compound, that will be given in the question. This molar mass you will have to do yourself. And this thing, that is a molar mass of detection compound. Okay, just remember this. Okay, tell me. This is all you have to remember. Now I'll tell you how from this one particular formula, you have all the formulas will be derived from here. Right? All the formulas will be, you just have to remember this and your qualitative quantitative analysis is sorted. Right? Now I'll tell you how percentage of sulfur, carbon, halogen, chlorine, bromine, iodine, all of this will learn from this formula itself. Right? Okay, tell me. No, you are super early to the class. I have just started the class. Acha, percentage of carbon. Now tell me, what was the detection compound in carbon? I told you there. In that method, I told you what was the detection compound. Tell me, what was the detection compound here? Detection compound is CO2. Okay? So I'll just write it here. Detection compound is CO2. Here detection compound is water. So in CO2, the molar mass is 44. Molar mass of detection compound is 44 CO2. Molar mass of carbon in CO2 is 12. Molar mass of water is 18. Molar mass of hydrogen, here is what? 2 hydrogen you have, na? So 2. You don't have to remember this. You just have to know it's a percentage of carbon, that is CO2. It's a percentage of hydrogen, that is water. That's it. Okay? Yes. Done. These two formulas done. Then next thing is Carius method. Carius method also will use the same formula. See, Carius method is, if you see, we have just done AgBr, AgCl, AgI, all these things are formed. Now calculate the percentages halogen calculation of percentage of halogen is curious. Same thing we will do. Theory part is same. We will present silver nitrate. Okay, all this thing, organic amount is heated with fumic nitric. Now instead of going through Lissagne's test, you are directly heating it with fumic nitric acid and then adding silver nitrate, and then that method is called as curious method. So in this case, what we will do, halogen is present in the form of this. You just remember that halogen is present in the form of AgX. Now let's see how we will do this, right? Bacha, do you remember the formula? Percentage of, I'll write percentage of. Firstly, let's talk about, I think I have written it here. I have written it here only. So we don't have to write it again. Percentage of chlorine. In chlorine, what you have? AgCl. Here this is AgBr. This is AgI. You just need to know what is the molecular mass of Cl. That is 35.5. Some students, they find this only difficult. See, learning these values is tough. 127, 235, 80, 188. Very high chances of doing mistakes, right? So just learn the molecular mass here. Of bromine, it is 80, right? And molecular mass of iodine is 127. That's it. And molecular mass of Ag is 108. Now, do this thing. AgCl, element is Cl. In this, it is 35.5 is the molar mass divided by 35.5 plus 108 is 143.5, right? This is mass of element, sorry, mass of detection compound. This is mass of organic compound. That I told you before only, what is small m and what is W. Same thing, molar mass of bromine, Ag plus bromine, molar mass of iodine, Ag plus iodine. Right? Understood? Okay, instead of remembering 35.5 divided by 143.5, this and that, just remember the molar masses. That's it. Okay? Tell me, everybody, if that is clear. Tell me, everyone. Yes? Chalo. Now, next is sulfur. In sulfur only, I'll tell you, just remember this is a detection compound. Just remember this thing. We'll see. I'll not tell you to remember so many things that you end up, getting confused. Okay, because this question also has been asked in 2025 for sulfur. Sulfur also has been asked in 2025 only. So, organic compound, Carious tube, you have this same thing, you do oxidized to sulfuric, all this, you have compound H2SO4, it is reacted. In the end, if the compound has sulfur, BaSO4 will be formed, right? And for that, percentage of sulfur will be molar mass of sulfur divided by molar mass of BaSO4. This is multiplied by M, multiplied by W, multiplied by 100. Molar mass of sulfur is 32. And what is molar mass of BaSO4? You can calculate that. Barium, I think it's, wait a minute, let me just see the, you can take it as 137, wait a minute. 4 into 60. 233, yes. Okay, so just remember the molar mass of barium is 137. That's it. Sulfur we know that is 32, oxygen we know 16. You add it and you will get your answer. This is still easy to remember, 32 by 233. It is easy, so you can remember as it is as well. Right? Okay, tell me. Is that clear to all of you or not? Is that clear, bachcho? Done, everybody? Now let's talk about phosphorus. Now I'll just mention the detection compound here. This is the detection compound here, that is M2 P2O7. So here, ma'am, mass of C, mass of phosphorus is actually 31. Okay. But here you have two phosphorus here. That is why it is 2 into 31, that is 62. Okay. Then you add P2, add the mass of Mg, add 7 into the mass of oxygen, you will get 222, which you can remember also. See, calculation also, it's totally, now you have the option, you can remember this thing or you can remember the molar mass, right? So that is 222 is easy to remember, so it is 62 by 222, mass of detection, mass of organic compound multiplied by 100. I have given you proper method that how we are doing it. Now this particular molar mass is very difficult to calculate if you do it in the exam, so directly remember it. It is 1877, that is a molar mass. Now here you have only one phosphorus, so that's why we have written only 31 here. We have not multiplied it by 2. Rest of it is same, M by W multiplied by 100. Right, okay. Acha, now one of the student asked me, ma'am, is it applied everywhere? See, it is not applied in two methods. First is Dumas, then there is Kjeldahl. Okay, let's talk about those two methods. Let's talk about Dumas method and Kjeldahl's method. So Dumas method is for estimation of nitrogen. So for that compound, what you have to do, I'll just tell you what is P1, V1, everything. See, P is the pressure. P, I'll just write it here. I'll change this to P and this to P1. Okay? This we will understand more when we will do the numerical. Right? As of now, just remember P2 is standard, that is always going to be 760 unless and until it is not given to you. You will take it as 760. T2 you will take it as standard, that is 273 Kelvin. This is mm of Hg. Right? P1 is given in the question. This is given in the question. This is given in the question, and this is also given in the question, where P will be the aqueous tension and wait a minute, let me just change this as well. P will be the aqueous tension and P1 will be the pressure. Okay, P will be the aqueous tension, P1 will be the pressure. Okay, understood? Now here, ma'am, what all we have to do, right? So if you write this here, so what all you have to do here is, remember that, just remember this all is given in the question. From here you will have P1, P, V1, T1. You know the value of P2 and T2. Calculate V2 from here. Firstly, in Dumas method, you calculate the value of V2 from here. It involves calculations, okay? So you calculate the value of V2 here, right? Once you calculate the value of V2 here, then either you can do this derivation and all, weight of N2 will be, this is number of moles multiplied by 28, that is the molar mass. Okay? Number of moles is volume by molar volume, right? So you can see this over here, that volume you are calculating in milliliter. Okay? Or you can just directly remember this formula. I would advise you directly remember the formula. In the exam, it will be easy for you, right? This is not the same formula that we did. Percentage of nitrogen is 28 by 22400 multiplied by V2 by W. V2 is the volume that you will calculate. W is the mass of organic compound multiplied by 100. and that will be your answer. And this is very important. This is Dumas method. Directly remember this thing. Okay? Right, everybody? Okay, everybody? Tell me. Is that clear? So that we have done. Now last is Kjeldahl method. In Kjeldahl also, if they ask you to apply this method, just remember this formula directly. 1.4 divided by mass of organic compound multiplied by normality multiplied by volume. Right? And this volume is also in liters, in milliliters. Okay? Understood? And normality is also taken as molarity multiplied by n factor. That also you must know. Right, beta? Now let's see how to apply all of this in the form of questions. Right? Tell me. Shall we apply it in the questions? Now, one thing you must know that Kjeldahl containing nitrogen, Kjeldahl is not applicable in what all things? It is not applicable in nitro and azo groups. It is not present in ring. If nitrogen is present in ring, then also Kjeldahl is not applicable. Nitrogen of these compound does not change the ammonium phosphate under these conditions. So basically, if you see compound, you have to change ammonium phosphate, right? That's how this will work. But in the nitrogen of this, it is not done. That's why it is not applicable. In nitro-azo or pyridine ring, where nitrogens are present in the rings, in there it is not applicable. So now this is the chart that I have made for you. Detection compound, formula with molar mass, everything is written here. You can see sulfur also, this also for phosphorus. This is another method of phosphorus that you have. This was NH4, I'll just write this here. This was for NH4 tries PO3.12 MOO3. Okay, that was the compound. And if you have this, then you will apply this formula. For Dumas, this is the formula. For Kjeldahl, this is the formula. Right? Tell me. This is the sheet that you have to remember. You said, and I have that sheet. Right? Color also I have made the sheet. This also I have made the sheet. Okay? Tell me. Done? Done, everyone? So that is done. So now let's see questions based on this. Your latest questions. JEE 2024 question based on Kjeldahl method. That is 1 gram of organic compound. That means W is given to be. You will see when I will apply this. Now, this is such a it's not a difficult numericals, right? Release ammonia. The ammonia released means that is following Kjeldahl. Neutralized volume is 10 milliliter. 2 molar. Molarity is 2. N factor of H2SO4 is 2. 2 hydrogens will be released. So normality will become 2 into 2, that is 4. Formula is what? Formula is 1.4. I'll just write this here. It is already written here. 1.4 into normality into volume by W. So I'll just put this here. Volume is 10. This is 1. So I think you will have your answer here. Right? Okay? 56%. So options are not given. So 56% will be the answer. You solve it, you'll have your answer. This and this will cancel out and 56 will be the answer. Okay? Right, everybody? Simple question. Now let's see JEE 2025 question that they ask you based on Dumas method. Right? So see the sequence here. Here calculations will be lengthy, but some students just looking at Dumas, they get scared. But it's actually not that it is. If you're good in calculation, you will be able to do this. Good means normal, right? Dumas method estimation of nitrogen, this much of organic compound. I always tell you organic compound is W, right? Give 60 milliliter of nitrogen. Volume is 60. Now V1 or V2, what is given? V1 is given. Collected at this temperature. What are given is always 1, 1. V1, T1, P1, P, all of this is given. This much pressure, that means this is P1. Aqueous tension is given to you. Aqueous tension at this temperature is 15, that is P, right? Then P2, V2, T2 we know, right? So you put P minus P1 minus P multiplied by V1 divided by T1 is equals to P2. This is P2, V2 and T2. Now I'll just put this all the values here. P1 minus P. P1 is what? 715. 715 minus 15, that is 700. So you can just directly write it. Volume is given to be 60. Temperature here is given to be 300. P2 is 760 is the standard volume that I gave you. It will not be given. You have to assume standard volume, right? V2 you have to calculate. Then T2 will be 273. Okay? From this value, you will calculate the value of V2 here. And that will be in milliliter. Right? Then you will put it in the formula. Percentage of nitrogen. That is going to be about 28 divided by 22400 multiplied by the volume V2. This will be multiplied by 100. Instead of W, you have V2. That's the only thing. Okay. Just remember, you know what? There's only one change that we have done here. If you remember, we used to write molar mass of element in that detection compound. Here you have N2 only. So it is molar mass of N2 divided by, here we used to write number of moles of the detection compound. That's why it was mass of detection compound by molar mass. But here instead of that, we are writing volume divided by this volume that you have calculated divided by molar volume. That's how we have put the number of moles. I don't know if you're able to understand this or not. If you're not able to understand this, just directly remember the formula, right? This is W, organic compound, right? V2 you will calculate, W is given to you, solve it, right? Okay, tell me. Understood now? What is the sequence? ID is Chem Catalyst Diksha is my Telegram ID, right? Okay? Yes. Tell me. Tell me everybody, is that clear? Will you be able to do that? After solving and all, you will get your answer as B is the correct answer here, right? Okay, students? Done? Acha, now next is the last question of today. That is 2025 question again. And I have taken some selected question. There are so many PYQs on the similar line you will see. In the Carius method of estimation of halogen, this much of organic compound, that is W, right, gave this much of silver. This much of silver means M is given, silver bromide is given, the mass of detection compound, mass is given, right? Percentage of bromine. Because molar masses are also given. So smart, na? They are so happy. So all you have to do is firstly write down the molar mass of bromine divided by molar mass of AgBr, 108 plus 80, that is 188, right? So multiplied by, this is mass, this is W, multiplied by 100. Is it difficult? Tell me. So 80 by 188 multiplied by, mass is given to you, that is 0.15. This is given 0.25 multiplied by 100. That's it. That's similarly you will calculate for others, right? Percentage of Br, right? Okay. Tell me. Bus session will end now. Last question, right? Now you have pointed it out on the right time. Done, everybody. That was about biomolecules and qualitative quantitative analysis. So officially we have, like, on this channel, on this year, the chapters that the chapters that you were asking for, that we had not done before, so I have completed those as well. So your syllabus I have completed. Now let's see how many of you want revision or pyqs. Do you want question practice, or do you want revision, good revision? Then do let me know what you want. Okay, understood. Chal. So that's it for today. Now this is, like, you can just solve, right? So that is the PDF will be provided to you in the description box and the Telegram channel. Now understand one thing, students. Here in the description box here as well, you will go to this link, right? And this link will open this particular thing. Now actually whenever I open it on my laptop, it shows, I don't know, if, tell me also if it is also showing in your, whenever you open this, three sections will be there: comments, doubts, and description, right? So in the comment section, so you will see the comments only of YouTube, but in the doubt section you can ask your doubts regarding the session, and you can also get your notes. You can ask, also give the quizzes based on this session. So everything will be there, right? Everybody, do let me know if that is clear to all of you or not, right? Yes, students. Chalo. P block I'll do in full block chemistry only, right? Okay, you tell me how do you want, because I also want students here to join in also, right? Because so much efforts it takes to firstly make PPTs. Dekho, in chemistry, so much in my head I am saying precipitates, right? So much effort it takes to make PPTs and then stand here for hours and hours. So you tell me in the chat box, in the comment section, what you want. Do you want question practice or do you want revision? Right? Okay, sure. Okay then, guys, now I'll see you all tomorrow. I have class at 6 a.m. in the morning, so I'll see you all at 6 a.m. Till then, bye bye, take care. Bye bye, everyone. Bye bye. And also write it down in the comment section. Did you like this session or not? Because your comment actually matters to me, right? It makes my day, right? So I'll see all your comments. Till then, bye bye.